Hello, everybody, and welcome to the Builder's Workshop. My name is Nathan, otherwise known as Old Man Builds, and we have Shawn Calderon here today. Shawn's going to present some stuff. So, Shawn, whenever you're ready.
Hey, thanks a lot, Nathan. I really appreciate all the support you give and a platform for me to share what I do in my little workshop. So I appreciate that. I'm just going to expand my screen here so everybody can see my slides. Nathan, can you let me know when you can see the slide? Nathan, you still there?
Sorry, we can all see it, Shawn.
Oh, okay, awesome. So hey, so what you're seeing here on the screen is it's my attempt in wiring a toroid coil. So if you see the grooves there, you'll notice that there's some shiny wire in between the grooves. And so what I did is I wound a 33 gauge wire and a total of a little over 12,000 turns of wire, even though it's divided in two pieces. Dividing in two pieces just made it easier to wind. If you're familiar with some of my other Tesla coil approaches, the Tesla coil sphere, some of the cylinders I designed, this one is in that same spirit of having thick grooves and then encasing it in epoxy and run some electricity through it and see what kind of plasma we can get. And so I wired some quite thick wires to the very hair thin wires. This way I could secure it uh, with some hot glue. And that way then nothing's tugging on these thin wires and I could start to see what I can do with this toroid. Now I had placed the red halves of the toroid in a green mold. And then what I do is I pour in the epoxy, and in my vacuum chamber is when the bubbles are drawn out, and it makes nice, real clear epoxy. As the bubbles, as you know it, in near high voltage, it can cause a lot of internal arcing, and so you can see this really messy job. I'm not really good at this yet. I'm still learning. I made the mistake of not placing uh, a coat of Vaseline on the inside of my forms. And so the green stuck to the red, and I lost that beautiful green and gold. And so now I've named this ugly thing the green donut. I don't know why it's animated here. Okay. So one of the things I do with all of my coils is I like to take readings on them and then just write what the readings are. So you can see on the left, I have 201 millihenries. It has 125 nanofarads of capacitance. Yes, when you wind big coils like this, you end up with a capacitor, and so it's always good to know your capacitance. And then up at the top left-hand corner, you'll see it's also 430 ohms, and the resonant frequency there on the left is 128 kilohertz. Now those are the specs on the left half of the toroid. I didn't know how much they'd come into play when I connected these up, but I just wanted to give you a little bit of insight on, instead of keeping track of a bunch of notes or writing a bunch of things down, it's just really easy for me to put all the data on the object itself, and then when it gets thrown in a box up in the cupboard, I can pull it down and know immediately what I can do with it. So this was going to be my first test. As you can see at the top of the screen, Old Faithful ZVS over there. And then on the right are a bunch of capacitors with a bunch of wires sticking out. Now I call this the tarantula because of course it looks like a tarantula. And I just got tired of looking for different capacitive values. And so what I did is I just threw 20 capacitors on a board and connected them in a whole bunch of different ways. And so I can get anywhere from a millifarad all the way down to 10 nanofarads in this setup. And then, of course, I like to nickname things. So that's the tarantula. Now, what I'm doing here is connecting it now to the toroid. even though the toroid looks like it's not connected, it actually is. I'm just leaving this space here because I don't want to seal anything off until I can figure out where the primary coil is going to go and how do I tune it. And then after that, I'll be taking a heat gun to those to the hot glue spots and then pushing it together so it's a complete toroid. And so this is one of my first tests. So I used an old 3D printer filament spool because it had the right dimensions. And so what I was doing is I was just placing different coils of copper pipe under the toroid to see if I could get some primary, secondary resonant frequency and see if we can get some plasma out of this thing. Now, those of you who are really good at this are going to see already the problem with this. But me being stubborn, I like to try it different ways because I feel like different geometries, different combinations, that you're going to stumble onto something big that somebody hasn't thought of because they're so focused on the math and this attitude of it's already been done before. So here I am, I'm putting a coil under it. It's definitely too far away, but can I get some readings? Can I get some oscillations? And so here I did get some oscillations, but nothing with near resonance. And so it was a failed test. And so I'm kind of showing you what I do here with these nice filament spools is I could just place the geometry in and then put it on tight. And then I can put on my different coils on it. And so this is kind of a cool trick that's worked for me. And so here it is. The tarantula, the faithful ZVS. This is the new ZVS. And then on the right, I'm going to get her fired up. If you see there in the vise, there you can see the O-scope probe. I do this for all of my high voltage experiments. It has a little piece of copper there sticking out. And within about 12 to 18 inches, you're going to pick up the frequency of what you're working on, the oscillations, multiple frequencies if they're being emanated and going on inside. And so this is a great trick to not blow up your O-scope, but yet really understand what your coils are doing and resonating. I took this photo here because I wanted to show you how thin the wire is that I'm working with. If you can look between the two here in the front of the screen where the two green donut halves meet, you'll see a little tiny thin piece of, almost like a piece of hair there on the bottom, almost not at the bottom of the screen, but in between at the bottom of the two halves. And I just thought this was interesting because when I get this thing tuned up, it's going to be throwing out a lot of power and handling a lot of current. But it's strange to me because these big rings inside this coil are all connected by a single wire. And it's a little hair thin wire. And yet it produces these large plasma arcs. And so I thought this was sort of an insight into what we are doing when we're dealing with these high voltage Tesla coils. Now, I could not find a geometry that worked until this one. So if you look over here, you can see that I'm getting some discharge. You can see it right over here to the right, the purple discharge, but look at that. You gotta love that. This is really how it is to experiment with these Tesla coils. If they're not perfectly balanced and you're like, oh, I got some breakout here, I'm onto something. All right, so I'm ready to close things up now and tighten things up and and we'll be able to get some plasma out of this thing. And oh no, wait a minute. Turn off the voltage, open up the windows, look for the fire extinguisher because I've set more things on fire than I should. Now, if you remember the earlier coil that I had placed the green donut on, and you'll notice that it was perpendicular to the windings of this green donut. But if you look at this copper pipe here, this copper pipe is in parallel with the windings inside the green donut. And because it's in parallel, what happens is it's allowed to then push and pull its frequency into the green donut because their polarities and their magnetism are the same. The gradient is the same. And basically that just means they're both wound clockwise. And then as the copper pipe pumps in 500-600 volts oscillation, that 500-600 volt is pumped into the green coil here with 12,000 windings, turns of wire. And then that's where you get the high voltage breakout. As puny and as weak this is right here, this is still about 10-15,000 volts. And for a first discharge after spending all day with different shapes, this means I'm on the right path. Now, of course, the fire means I'm not on the right path, but this is progress. And so I thought I'd just kind of give you a little insight on how I test these coils. And I'm going to keep working with the green donut until I can see it really produce large plasma. I have a feeling the plasma is going to be different because of the shape of the magnetic field, the electromagnetic fields that are created. So I'm pretty excited about that, but it was a lot of steps to get here. And so I'm pretty happy to share these with you guys. All right. So Nathan had suggested or made mention that it was pretty cool to put the primary of the coil inside the secondary of the coil. And so I thought, well, let me play around and see if I can get something worth watching. So I spent like a half an hour pulling coils down. I wound this gold coil here. You can actually, let's see, can you see it better here? Oh, this is a better way to see it. So I wound 900 turns of 32 gauge wire on the left. And then on the right, I wound a conical primary coil, the conical shaped pipe in the right. It's not too conical, but it's just, you can see that it's angled in toward the top. But I did this because I'm going to place it inside the Tesla coils and see if I can get some plasma. And so this is the top view here of that that geometry inside this Tesla coil outside. So I turn the thing on and I'm putting 24 volts, 1 amp. And we can see there's the ZVS. And what am I getting? Not an outbreak, but I'm getting some radiant power. Notice how you can't see the primary on the outside. So this was a start. I mean, at least it's on the right path. You can see the two little pipes coming out the bottom, but really the primary is inside the secondary. And so that's the approach that I'm staying with here. And so I showed you this earlier. Oh, I probably mentioned this too. So I cut pieces of foam. Anytime I get packing foam, this is black packing foam. And I keep stocks of it because it's a super good insulator. It's pretty fireproof. And it's moldable where I can put it in shapes like it's holding this copper needle for me right now. I don't have to cut wood or plastic or glue or anything. I just cut this spongy stuff, tuck it in, and boom, I have support for my high voltage output connections. Let's see here. I think we just saw that one. Okay, this is, I want to say this is 42 volts. I'm going to use my switch so you know it's DC. And look at that. A Tesla coil with the primary inside and the secondary on the outside. And that's a pretty respectable DC output. You could do some more tuning, but I just sort of felt like there's a tarantula. I felt like that was good. And I'm not sure why I'm doing a close-up here. Oh, to read the frequency, 357 hertz. So let's see here once this video ends. One of the things that I learned in trying these different coils is these smaller coils, they have higher resonant frequencies. They're in the 400s. And so one thing I discovered was the ZVS, it just was sluggish when I got it to 400 hertz. Even 395 kilohertz was good, but 400 kilohertz, it just kept, no matter how low I would change the capacitance, no matter how much I would change the variables to try to get to 400 kilohertz, it just didn't want to. And I think that's just a limitation of the MOSFETs that I have in the circuit. The diodes are pretty fast, so I'm not too worried about those. I really believe it's the MOSFETs. And so I did a little bit of research on MOSFETs, and I'm finding out that though these MOSFETs are good all around, all purpose, they're not the best for switching. There's actually faster switching MOSFETs. And I had drawn a grid to kind of find a inexpensive, faster switching MOSFET. And I don't have it here on the screen here, but I'll just tell you the numbers real quick. So the 260N, which is what you're seeing here, it has a rise time of 60 nanoseconds, a turn on time of 17 nanoseconds, a turn off delay is 55 nanoseconds, a fall time of 48 nanoseconds. Now, you're probably saying, what does that have to do with anything? Well, let me pick up a quicker MOSFET. It's a 240N. Instead of 17 nanoseconds for a turn on, it's 14 nanoseconds. Instead of rise time being 60 nanoseconds, it's 51 nanoseconds. Instead of turn off delay of 55, it's 45. And fall time, instead of 48, it's 36. And then if you look at the stats on the 240, they're almost similar to the 260. I thought I'd just throw that out to you because I'm going to order these 240s and see if I can get past that 400K threshold. And I'll get back with you guys. But I know those who are on the call who play with MOSFETs, I thought they would find that helpful and save them some research. This is just one of my tips. I don't have to wipe everything or paint everything with polyurethane. I go to Walmart, I spray this on my coils, and I get no internal arcing, and it's great. Great way to go. These are cheap, and highly recommend them. I literally spray everything with this before I put it in epoxy and want to do the hard testing. I'll just put a few coats of this. So this is the different shape that I created for the inside primary. It needed to be conical. Let's see here. Okay. This next thing I'm going to show you it has to do with a friend of mine, Nick Fenning, and he has, and you guys know him by this, he has the Merkaba or the Merkaba, that amazing machine that surrounds a spherical magnet with 6 coils, and he has drive circuitry to send out electromagnetic pulses of the 6 coils to point to the center, and then a spherical magnet spins at unbelievable speeds. And so he and I go back and forth and brainstorm. It's more him than me because he really knows his stuff. But I kind of pick his brain on things or make suggestions. And so a problem he was trying to solve was when his magnet spins, his Arduino at 32,000 hertz, it starts to go haywire and starts to count backwards or go negative. And so he was asking me how, because that little sphere spins over 30,000 RPMs, and he wants to know why it bugs out after that. And so what I did was I contemplated it for a couple days, and I wired a magnet here. Let me reset this here. Sorry. I wired a little microphone, and I put it next to a speaker, and then I played my signal generator into the speaker to see if the microphone was picking up the output of the speaker correctly. I do it again here. See the microphone I bring up to the little speaker? And then here I look at my signal generator, it's 800 hertz. And then if I look at my oscilloscope, it is showing 806 hertz. And what I was doing is this little cheap condenser electret mic has a little tiny potentiometer, and you can use your little screwdriver and you just tune it, put it up to the speaker, look at the signal generator, okay, 800 hertz. And then you look up at the O-scope and we have 806 hertz. So that's what I was doing, is I was adjusting this little cheap, oh my goodness, like a $2 microphone. And once I had it tuned, I took the little microphone and put it up to the speaker of my iPad. And then I was playing the YouTube video of the Merkaba. And if any of you guys listen to the Merkaba, let me see if it's this one here. I do it. Let's see. Sorry, that's not the right one. I have a double video here. Sorry about that. Let me pick the right one. Here we go. So there's the YouTube video there on the right, and I'm hitting play, and it's squealing louder and louder and louder. I mean, the squeal is incredible. And see, I'm holding a little microphone out to my iPad speaker, and then listening it to go squeal louder and louder until finally it sort of settles out. And then I can look over here and I can see that there's a frequency of 741 hertz. Okay, so the output sound is 741 hertz. Now with a little bit of math to convert this into RPM, he ended up with 42,000. Sorry, I put it on my phone here. 44,460 RPMs. And this was just a little 15-minute try, and I was really surprised how accurate this was. And so Nick Merkaba, he's still going to stay with his really high-tech sensors, but I asked him if it was okay if I used my sound and microphone setup to compare frequencies and RPM. It might just be a nice way to verify his results as he gets that magnet to speed faster and faster. Another cool thing about this approach here is I had originally bought these microphones because I wanted to place them between a speaker and let's say a piece of metal. And I wanted then the speaker connected to my signal generator and do a sweep. So start from 1 hertz and they'll climb up to 10 hertz, then 100 hertz and 1,000 hertz and climb up all the way up to 1,000,000 hertz. And as I was doing that, I wanted the microphone to be picking it up on the other side of that piece of metal was resonating with one of those frequencies. And then my hope was to then put an electrical frequency as well as mechanical frequency into a piece of metal, because that sounds very fascinating to me. And I can't find anywhere where people are really doing it. And so I had these microphones laying around. Hey, let's put it up to my iPad speaker here. Boom. Wow. I think we have RPMs of an amazing machine in England from the iPad speaker. So that's a close-up. The microphone outputs a square wave, which is nice because it's a little more accurate, or it's easier to get the hertz from a square wave. and they're 741 hertz or 440. I'm sorry, 44,000 RPMs. Now, this is when I first started. I thought I'm going to just keep putting coils on top of the primary and test it. So this is another coil I'd wound. This is 34 gauge, and the other gold one was 32 gauge. So this wire is so fine, it's no fun to wind. When I lit this one up, when I applied power, you can see that it's not arcing from the top, it's arcing internally inside. So I don't have a balanced system here. What's happening here, which is really interesting, the red wire here is pushing electrons through the PVC pipe and into the inner coil. And so if you guys, let's play it again here. If you guys remember, I put the coil on the inside. What's happening again is the 34 gauge wire on the outside is pushing electrons through the PVC and into the copper piping. And of course, that's not desired. But it did something interesting. And what it did is when I looked inside, and everything's fractals, right? I think Victor will love this. So what's coming off my primary coil inside are 2 touch points of fractals. Now you have to think about this. That thin wire on the outside reaches through the PVC, pulls electrons from the copper pipe here. But in doing that, it creates this beautiful fractal structure. But what's amazing is this thin 34 gauge wire doesn't even have a nick in it. Smooth and as beautiful as you're seeing it here. But on the inside, it's laying waste to the inside of the PVC pipe. And so you can see these little scorch marks right here on the copper pipe. That's what led me to designing the different geometry that works. And that was that cone. Different angle, pretty cool. And so, okay, well, if the cylinder primary doesn't work because it arcs, let me put a bend and make it slightly conical. And so that had been what the solution was. And I mention this because if you're putting a primary around a Tesla coil, you're wrapping this copper wire around your Tesla coil, and it's arcing and sparking, hey, get some space from it and leave the other windings of pipe alone, but just change where it's arcing and sparking. You might get a fun geometry like this one, and then also you'll get a very unique creative Tesla coil. So you can see the 2 marks here, and but the style here is also interesting. I'm running one of the pipes down the center, and I didn't know if this was going to work. I thought maybe that the internal wire going down the middle here would start arcing and sparking, but I had no problem with that. The only problem I had was I needed to have a conical top. I needed it like this. So from this to this. Another angle. And now it's in there. And the red Tesla coil now works quite well. It's all connected up to the ZVS. And let's see on the O-scope. Yep, that's beautiful, what we want. There's something a little bit different about the resonant ringing wave there when the primary is on the inside instead of the outside. And maybe that could be a topic of discussion. Okay, so I'm going to run some DC or AC through it. Now remember, the primary is on the inside. So I didn't have a whole lot of time to tune this, but just a little bit of tuning, and you don't need your Tesla coil primary on the outside. You can just stick it right under and it'll work like a charm. One of the things that made this easier is if you look at the bottom of the red coil, there's like a 1-inch space of PVC. That was really kind of necessary in order to get this balanced system. I have a cone inside the red coil. I have a 1-inch space at the bottom of the red coil. And then I just pipe out the two 1/4-inch copper pipes out the side, and boom, this is the balance system. This works. This is probably like 1,100 turns of wire. It's about 3.5 inches wide. I can't remember, maybe 13 inches tall is what I'm thinking. Okay, so this is one of my tips. I smell ozone, and I don't know if it's going to hurt me or not. So I picked up this ozone meter, and whenever I'm doing my experiments, I'll just kind of run this around the room. And I wasn't getting a lot of ozone, so that's good in this test. But there's been some times where it's been in the moderate and then in the serious. And I have a very sensitive sense of smell. So I kind of tune my nose to this. So when I smell things that are moderate, I'll bring it in and, oh, yep, it's moderate. And what I read about it is if it's in low doses, it's really good for killing germs and making a sterile environment. But if you get into the moderate or serious levels for too long, it's going to cause agitation to the throat and to the lungs. And there's no really good long-term um, health benefits when you're in the moderate to serious. And I care about my lungs, so I'm just gonna keep this thing around. And if I start seeing it go to slight, heading to moderate, I'm gonna start figuring out some different ventilation. Thought I'd share. Got it on Amazon. It works really well. It gives temperature, humidity, and all kinds of other cool stuff. So I love collecting different types of data. Thought I would share. Then here I'll just stand it up. So I'm running stuff through the coil. Okay, my ozone is, smell it, but it's still pretty low. So let's see here. I think I have one more. Let's see. I think this was the last video. So I thought I'd just end with a good old sear, putting in it about 60 to 70 volts, enjoying the tendrils, and it's just kind of hypnotic, and there's just something special about the plasma from the sphere that I just enjoy. And sometimes it's just nice to watch. So I thought I'd close with this, and then open up the floor for questions. All right. Oh, and beautiful ring signal, perfect resonance. And that's done. That's the end of my presentation. I want to thank you guys for your patience. Not a lot of exciting things, but just an idea of what's going on in my lab week to week.
Thanks for that, Shawn. I really appreciate you presenting.
Thank you.
Yeah, that was really cool. I like the Tesla coil with the coil on the inside. That was just awesome to see because I've never seen it before. Looks like I'll have to make another video for you.
I appreciate that. I hope changing of the dimensions made sense. How you just, where it's arcing out, just make it smaller. Just start tweaking. Don't be afraid.
Well, what's cool about it is in that one, you moved them in towards the center, right? And then on the other one, when you did the sphere, you had to move them out at like 30 degrees. So
yes, right.
It makes sense in geometry what's going on here and what it likes to do.
And I'm more just frantically trying different ways to do it. And then I brag that I'm real scientific and get it working.
Here's a message for you. Have you tried using more sine waves and seeing what effects it has on more plasma?
So that's a good question about, there are two inputs that I use. One is DC, and the direct current hits the ZVS and it oscillates at the resonant frequency of the capacitor and that 3-inch quarter pipe coil. And if you're lucky to get the capacitor and that coil to oscillate at the frequency of that secondary coil, then you're going to see some arcs and sparks. Now, when I put in a AC, I can't put in a strict sine wave because the circuit's not made to go into the negative voltage. So as you know, a sine wave is like an S wave. It goes up into the positive voltage and then it goes down into the negative voltage. And that negative voltage will basically cause harm to the ZVS. Now, there's probably some way to change that, but I've been kind of more focused on getting my coils all working first. So it's a good question. So when I put AC into it, it's not real AC. I take off the negative pulse, and so it's you could say is a positive pulsed DC would be a way of saying it, or it's half bridge, half wave rectified.
Okay. All right. How do we get the tubing not to kink?
Yes. So you fill it with sand and you cap it up, and then it won't kink. And then I have a little rubber mallet and I tap on it, or I put the gloves on, the Spider-Man rubber gloves on, and I get a little like piece of PVC or something, and I start Indian wrestling it. The forms are not easy. That cone was not easy, especially to twist it to go down the middle, back down the middle. And so good catch there, Victor, because yeah, they're not easy to wind, but yeah, sand is I have a bag of real fine sand here, crafting sand, cap it up, and then yeah, you'll never get a kink again.
Okay. I got another question for you. Your donut coil.
Okay.
Would you put rings on the outside like Saturn right in the center?
So if you look at the donut coil from the side, the coiling around it is vertical. Okay. So when I put that other coil at the bottom of it, that coil at the bottom of it with the 3D filament spool that I did,
Yes.
that made the primary coil, the copper pipe, that made it perpendicular to the inner windings of the donut. For a Tesla coil, you cannot have a perpendicular winding to the secondary winding. You have to have the primary in parallel wind the same way as the secondary winding, if that makes sense.
Okay, so if you wound the donut the other way, you'd be fine doing that, but this way it just won't work.
Correct.
Okay.
Correct. Yeah, it's now I did try it though. I tried so many different ways. I didn't have time to take pictures, but I did try a Saturn type. I tried the concave, reverse concave. I mean, I tried some shapes, and I knew I was trying to break physics. So I didn't get to break physics that time. I had to at least play nice and get something on the camera for you guys.
Nice. Hey Ben, you got any questions?
I kind of dropped in halfway through his presentation, so I'm gonna have to go over the first half before I dive in anything. So I'll have to catch up with Shawn on that one.
What were your thoughts on the Tesla coil with the #1 coil on the inside? Did you catch that one?
No, I didn't catch that.
Oh, I love the beautiful glow on the inside, even though it was like harmful fire probably. It was so awesome to look at.
The fractals, the creating of the fractals.
Yeah, well, the creation of them, how everything in there, because the white on the top of the Tesla coil turned to like glowing because of the color on the inside.
Yeah, it's it destroys your work, but it's like a firecracker. They're fun to watch.
Yeah. Try it and find out. Shawn took it seriously.
Well, it's definitely unique research on Tesla coils. I've never seen anybody looking into doing this stuff with Tesla coils before, you know.
I appreciate that. I can play that again if you want.
Yeah, what else did you notice about the primary and the inside? Okay, so is the outside any cooler? Is the inside obviously must be hotter? So did you notice any of that? Also, the range seemed to be like nothing.
Yeah, I did use the infrared, and everything is cool as a cucumber. There's no heat at all, inside or out.
Really?
Of course, when I was torching it and it was catching fire, yeah, that was hot. But But when I was made it conical inside and there were no more arcing, then it was zero heat. And I always like to do it because the ZVS has no heat, the Tesla coil has no heat, and then those little alligator clips that I made homemade, cheapies, they get hot. And I never really do a build where I have thick enough alligator clips. So that's the only thing that gets hot.
Wow.
Yeah, that's pretty cool. Literally.
Yeah. Yeah. I have that video if you want me to run it real quick.
Yeah.
Yeah,
Hold on. Let me put it up. There we go. Go ahead and go big on your screen, Shawn.
Okay. Let's see. Present. It's saying stop screen.
Oh, you're not sharing now. You stopped.
Here we go. Here we go.
You gotta share your screen again.
Can you see it okay?
No, you gotta share your screen again. When it says stop screen, that's talking about when you're in StreamYard.
Okay. Sorry. I'll get here. You don't want a left-handed dyslexic figuring it out on the fly.
It's okay.
So
I think we all have a little bit of that.
I think so. I think we've all here we go. If you guys can see this.
Gerald always gets me by putting the lowercase first and then all the rest of the letters are capitalized. And my mind absolutely cannot function with that.
Oh, man. Okay. It's up, but it's not.
There you go. All right, go ahead and hit play.
All right. This is what Nathan liked.
Yeah, there you go. Look at the light up in there.
Yeah.
You're still getting plasma too.
It's smoking.
It's lighting up the PVC. It's like lighting the PVC on fire. Is that what's going on?
Yes.
Yeah, it's creating fractals in there.
Yeah, I seen the pattern for a second on one of the images.
Yes, exactly.
Have you shown the tried to shine a light through it yet, or done any kind of projection, like mapping?
You know, yeah, the PVC is too thick.
Maybe you could sand it down a little bit though.
I'm thinking of using the clear acrylic again, and purposely zapping it.
That way you can.
That way,
see what's really going on.
That is.
That sounds really cool because then it would show up as an image on your wall, wouldn't it? As you're creating the fractal.
Yeah.
Oh,
it'd be very cool.
Yeah, he ran the test once, and I thought it was so cool. Like I would never have thought of to do that, but that it shows you like in clear as day the fractal patterns.
Yeah,
it's so incredible how fractals appear everywhere. If you're willing to look for them, willing to see them, it's amazing.
Well, it's a mathematical fact that they're going to be there.
Right. So how are we doing in the chat?
We're doing good. Everybody's in there commenting. So I'm just looking for questions. You know, a lot of people watch that video of your Spear Tesla coil, and absolutely amazing. They all love it.
Oh, I appreciate that. I was real touched by you doing that, Nathan. Thank you. It's worth noting to the guys here and gals that Nathan just, out of the kindness of his heart, does these nice things for me. And I can't thank him enough. I really appreciate it. I never have to ask, or he's inspired, and he's a heck of a whole lot better than me at it. So
he's just a great guy all around. No, he does nice stuff for me too, and he's like my mentor. So
yeah, I would say that mentor, definitely a leader for this group. Yeah, I believe.
Exactly.
Thank you, guys. You're too kind. That's for sure.
We'll follow you into the unknown, Nathan.
Well, we're getting there, huh?
To infinity and beyond.
we all keep seeing things we've never seen before. That's what's amazing. You know what I mean?
Yeah.
So we see a sphere Tesla coil. Now we see the primary on the inside. Now we're going to get a fractal show with some lights and stuff. That's going to be amazing.
Yeah.
I can't wait. I'd like to get a fractal presentation from the plasma and then derive coil winding jigs that are exactly shaped so we can emulate the designs in coil winding. That sounds really fun to me. And just take them straight from the laser through the fractal images. And I bet some of the coils that we're winding, like Ben and oh boy, those kinds of Rodins and star coils, I think those will show up in the 3D representations of the fractals. Let's see here. Victor's asking high frequency capacitor values. So you want to stay with an MKP capacitor. I go for the WIMA, which is WIMA, but the MKP capacitors, and you can go as low as 630 volts. That's fine. You can do a lot with 6,000 volts and still save money. Specifically, what I get are the WIMA MK10s, 220 nanofarads, 1,000 volts. Those are the ones that I put on the tarantula you saw. And on the tarantula, I'm getting about 15 different capacitor values, so I don't have to buy those. And those capacitors can take a beating. If there's another way we can connect, Victor, I'd always be happy to mail you links or more information on what you need. Hope that answers your question.
Right on. Real quick, this one's for me. Could you get an update on the Gravity Flyer? Basically, Shawn and I were talking about Tesla coils in the ground, okay, and Tesla's third energy. It ties into the Gravity Flyer and what I'm doing. So I have my Tesla coil on the ground. I have a rod into the ground, and I'm pumping the ground right now for ether. So, and I have my Gravity Flyer on the ground, which works as a secondary ground. The grounds are connecting underground, and it's creating something awesome. I'm not ready to show it yet, but I have been diligently working on it, and there is going to be some updates soon enough. Just not there yet. But I'm getting a ton of energy. Let's just put it this way. The energy is pretty much limitless, depending on how long you want to wait for it. And yeah, it starts frying things on the system, plastics, if you know. So
you got to be careful.
Yeah, you got to be careful. Well, when you go into like hours of testing, yeah. So
yeah,
generally, you know what I mean? It's 30 minutes and then, you know what I mean? You're good. But that Tesla coil is a pump. I keep telling people it's a pump. So what I'd love to see, and I think we're past the season, but we might get it. My ground in the front yard, okay? It is like 8 inches of rock. It's 4 inches of sand above that. And there's piping all underneath. And then I have fake grass on the top. So it's a perfect water area when it's wet. It'll fill up, okay? And it's all going to drain to the pipe. But if I clog the pipe on both sides of that, I can get it to pool. Now I could take the electricity and use the water in between it from the rain, because the rain has fluoride in it. Now I can actually push a lot more power than that. So kind of have some experiments going on this stuff. The Gravity Flyer is tuned perfectly. I don't have an issue with that at all. And I'm just working on the Tesla coil. I may have to go to a fatter Tesla coil than the one that I have. It's only because when you get so much power in something, it likes to arc on the inside, like Shawn was showing. So I just call it the light show. And I want to kind of probably put it out to a 4-inch, and I might just take one of my bigger coils, like my red one that's behind me. I don't know if you can see it. Probably, yeah, there it is on that side. And I might start using that one out there and getting it going that way. But the only thing is that one connected to my gravity flyer will put me in double-digit hertz. So it'll be like 15 hertz, 16, 18 hertz. So maybe even 30 hertz, but it won't be the other one. So we'll see.
Wow, thanks for that update. I'm excited to see the update when you're done filming it. It's going to be exciting to see those effects. Combing through the chat here, Wizard of Woodstock says 430 ohms, thin wire, Shawn. Yeah, so a straight piece of wire, even 100 feet of wire, could just read 0 ohms. But when you have 12,400 windings of thin wire, yeah, you get 430 ohms. In fact, the whole toroid is almost 900 ohms of wire. So good question. ZBS good, but not as good as a relaxation oscillator. I would go to it, but it always puts me to sleep. So thank you for that.
Oh,
I've looked at relaxation oscillators. I have a 10 component rule like Nathan. So yeah, I mean, the ZVS already pushes me to 12 components. So I feel a little dirty, but I'm okay. Sometimes plasma is a waste of energy. In experimentation, plasma is a huge waste of energy. Not on the sun, though.
So I just real quick, he says, Joel, I want to get this right. Lagans? Is it Lagans? Okay. Would come on if you asked him. I will absolutely ask him to come on, and we'll do a Monday show for him. No problem whatsoever. I love the what is it, the peg battery or peg circuit? What does he call it, Ben?
Is it the hairpin circuit?
Peg cell.
Peg cell. Oh.
Yeah, so absolutely no problem there. Sorry, Shawn.
No, sounds good. Awesome. Wizard of Woodstock says red color is higher current, blue is higher voltage. I'd love to check that out. I honestly, I don't know. I mean, I feel like the higher the voltage on the Tesla coils I'm working on, the wider they are. The lower the voltage, the more purple. And I don't know if you've looked at a lot of Tesla coils, but the ones that I've been working on are super purple. Somebody in the comments said that I'm looking rather purple and fluffy. That's an example of how dark purple. I just think that these Tesla coils are unique in their outputs as well.
Mm-hmm. Yeah, usually you have to have for the novelty plasma balls to get some kind of effect like you're getting. You have to have it contain and have like a bunch of noble gases or something in it, to excite it. You're just busting it out.
You're totally right. That's a good comparison. Good comparison. All right, I'm going through the chat still. Like and subscribe, guys. Thank you, Woodstock. Relay is better than a Mosfet. Woodstock, I think, is trolling.
I thought so too. He's having some fun.
Yeah, he's having some fun.
We love you, Woodstock. I mean, I believe it or not, I have the plans for a plans for a relay Tesla coil, and if I get enough interest in that, I'll build it. But the switching of a relay is way less. I mean, it's a physical switch. Mosfet can switch. What was it? Turn on time was 50 nanoseconds, 50 billionths of a second. Yeah, I think the relay would explode in microseconds, let alone nanoseconds. But he's thinking outside the box.
Okay, I got a question for you. How about taking a jar and putting it over the actual plasma that's coming out? What would you get?
So as far as letting it sort of create a different environment inside the jar and then see what it does with that environment instead of having fresh air.
Yeah, would it interact with the actual glass itself? Because I've seen a lot of Tesla coils interact with the glass.
The ones that interact with the glass have a whole lot more power
Okay.
than my Tesla coils. My Tesla coils are very high voltage, but they're very low current. So yeah, I've tried it. It doesn't have the power to do it.
Yeah.
I have a 50-pound neon sign transformer that will push enough power through glass, but not these guys. I'm all in for a million volts on your desktop, but definitely won't have the power to do that. It's an interesting question, though. So someone asks here, sine wave good, but sawtooth wave better. I'm working on a sawtooth wave for Ian. Ian's doing something really cool, and he needs a sawtooth wave. And I'm not sure if you guys have ever looked into sawtooth waves, but you have to add sine waves. And if you look it up, it says you need to add an infinite number of sine waves to get a sawtooth wave. And so I thought, no, it's outside my 10 component limit. And I don't like IC chips. I refuse. I feel like I'm closer to Tesla if I don't use IC chips.
Yeah.
So I just did a demo of my new sawtooth generator using no IC chips and no infinite sine waves. And I will be inputting it into my Tesla coils and sharing that in the next week or two. So
Yeah,
I'm glad you asked.
Eliminate all those potential points of failure. That's smart.
Thank you. Yeah. And right now those strange lightning bolts that you get, the purple swirls, that's a round wave, round pulse going in. A sawtooth pulse will definitely have different characteristics, so it should alter the plasma output since it's a different wave, if that makes sense.
Yeah,
Be interesting to see. Go ahead, Ben.
Oh, no, I was just agreeing. It makes sense. Yeah, no, I would like to see something like that on the oscilloscope.
Yeah. I might do some more show the oscilloscope for different wave patterns. Might help too. So what do you guys think of the condenser mic?
I'm sorry?
What do you guys think of the microphone reading the RPMs of a guy who's spinning a magnet in England?
Oh, I thought that was cool.
Was cool, yeah. And I really, really, really loved the little mini potentiometer. That was my favorite part, to be honest. I'm a sucker for those little tiny components.
Yeah. I bought a string of those because when I first saw Nathan's video on the Graviflyer, I'm like, I'm gonna have to figure out how to figure out the resonant frequency of everything in my house. And then I got hooked on Tesla coils, but I always thought of Nathan with that. And I was surprised the little microphone worked. I was so surprised.
Yeah, you never know. Try it,
Yeah, but Ben, that might be something for you here in the future when you get your balls spinning.
Oh yeah, for sure. Yeah, I'm gonna have to rewatch this video and check out that because I caught the end section of where you were talking about it, but yeah, we do have a bunch of mobile options now. That's really awesome. Like I got the mini stereo amp board, which is working really well. It's an AB class, and yeah, done some testing with that, and it's working really well. And it's like this big, 12 to 18 volts.
Wow.
Nice.
Yeah.
Sounds good, Ben.
Was it one of those little things we were looking at that one day, or is it something different?
Yeah, it's the Drox. I believe I sent it to you. Yeah, it's a little $20 one. I'm like, yeah, why am I going to spend all this money on these expensive stereo amp receivers? Let me just try this, mini board. And it worked perfectly,
Nice.
So
you have an aptitude for it. You're a natural engineer.
Oh,
I can tell in your
builds.
I can tell how you're you're an outside the box engineer, but yeah, it's awesome. I learned so much.
Thank you, Shawn. That means a lot to me because I always consider myself to be like an amateur at best.
You know how Nathan will just go endless on the Gravifly, or I'll go endless on the coil, Tesla coil. You'll go endless on the Rodent coil, and it's all just straight amazing. So don't underestimate your knowledge, because you're an expert on it, and we all want to learn how to do it. So where are we going to go? Well, we have an expert, so that means a lot.
Right. And Michael Morels, we need to get him back on the show because he's doing some amazing work as well with the Rodent coil. I'll have some updates for you guys next week on that, but suffice it to say, he's done some really awesome work.
Awesome. Lots of love in the chat. So I'll just say it. Love all you guys in the chat. You guys are awesome.
Yeah, we have the best audience. I mean, like I was the audience, at one point,
I can say this, Ben, you're way ahead of me on that coil right now. Way ahead of me.
Well, Michael's ahead of both of us, and I need to kind of try to figure out what he did, because he's getting 10 times output, and it's extraordinary using just a little simple circuit, not taking a lot of power without the stereo amp receiver setup. So that's what I'm doing right now. I'm having a little difficulty trying to replicate what he did, but I got some new transistors on the way. So Friday we'll have the exact circuit that he used. But who knows? Maybe we'll get lucky. Maybe not.
Sounds good. I keep my eye open for scientific papers that go through the journals. I used to read a lot. I don't read as much as I used to. But if a headline catches my eye, I'm always thinking of us in our fringe think tank. And one of them was how they figured out that photons can go back in time. And they set up this apparatus, and this is all peer reviewed. These are all university professors. And what they found is that photons were leaving the device before they were entering. And just them even saying that freaks them out, because they all, know there's no backward in time. But here they have photons leaving before they come. Thought that was cool. Another discovery, and these discoveries always get me because they're done by a bunch of university smart people, but they're always saying about they're surprised how simple it is. They didn't know that you can get something from so simple. And I think that's kind of why they miss a lot. And it's true. It's so true. And so some scientists just said, you know what? This is below us. This is too simple, but we'll try it. We'll have the grad students, our indentured slaves do it. And so they built this rotor, this little piece of, it's a cylindrical piece of metal, and they spun it at a certain speed with a coil on each side. And at the certain frequency, that rotor began to become a magnetic amplifier. It amplified magnetism. Now, when you look up how to amplify magnetism, it's super complicated.
Yeah.
So just spin something. And I thought of you guys because I thought, that's what we do.
Yeah.
You know what? There's a whole lot more to geometry and velocity and then people give credit. And so we'll take the low hanging fruit. You guys keep your head in the clouds. And so I just thought that was so cool. And there's a lot of applications for it. So it's like a big find, but it's been right under their nose because it's just a spinning cylinder of metal.
That's interesting. I mean, with magnetism and electricity, they're just two aspects of the same phenomenon, really. And with the Rodent coil, you're taking the geometry into consideration with the electricity. Yeah. So with the magnetism, you're maybe taking the geometry in consideration there to amplify the magnetism, I'm assuming.
Yeah, that sounds right. It's so fascinating. Yeah. Sounds
yeah,
right.
That's cool because I've never heard of a way to. I've never actually looked into amplifying magnetism.
Right.
Like I'm so focused on energy production and stuff like that. Like I haven't even considered that.
I could have told you that a long time ago.
Oh
Soon-
yeah.
As soon as you put high voltage on a disc and spin it,
Uh-huh.
it'll create a heavy charge on it because
Oh.
each one of the little spikes on the outside has to create a new like little tendril that goes down to the plate. So it continues to do it every time it spins. So the faster you spin it, the more that you get. The more that you get, the more magnetism is created. But it's not exactly magnetism, it's charge. It depends which state you're in.
So but it's still creating a field. That's awesome.
It creates a
and depending on
massive
how
field.
fast you spin it, you can create the stronger field. Oh, neat.
Yeah. So here's the thing right here. Okay. I've been meaning to ask you what exactly you guys trying to do here. Okay.
What aren't we trying to do?
Okay.
Let me give you a quick version answer. Okay. Ready? We're going to take a coil. We're going to make a magnetic field around it. In that magnetic field, once it operates, we're going to create oscillation that goes this way and also this way. What it's going to do is create sound waves that go over it, okay? In those sound waves, they're going to go up the vortex right here, and they're going to create a pattern. In that pattern, we're going to be able to take it and transmutate objects, okay? That's going to be the basis of what we're doing. Now, there's fields involved here. You got a magnetic field, okay? You're going to have your sound fields that are going on, okay? You're also going to have geometry that comes into play on exactly how you make every single frequency that comes out of it and why you're doing it. And they all do certain different things based on the way you set your coil and adjust everything. Now, with that all said, what is this? This is the key to our planet. This is the very key to making a UFO work correctly. This is how to put something in resonance. This is how to build fields. This is the holy grail of what you want to do. It takes into account mathematical formulas. It takes into account the actual geometry that they don't put into your stuff, right? Pythagorean theorem. It's going to take in your fifths, all your sounds, all your octaves, everything. It's going to take into all your vortexes and everything, okay? We are going to create the perfect system. And we are almost there. That's the insane part about this whole thing. Yeah. We are almost there.
Wow. Well, I'm going to have to re-listen to that. My head's exploding.
Good I told you it was a quick version.
Do you have a diagram of that?
I'm working on it. It's going to be like a 3-hour video, but it's absolutely worth it. I've been on it for like a week and a half. It's a lot of different facts, fractals, things that show up in there, frequencies down, how they interact with the actual winding of a coil. Go ahead.
You summon Mike Faraday with your awesome lecture there. He's in the chat. What's up, Mike?
Nice.
I'll send him an invite if he's out there, and I'll also send one to Victor.
I have a question in the chat here. I think it's for Ben. Would it be worth investigating a generator using 9 rodent coils, let's say suspended with the centers of the coils forming a halo and cycling a magnetic sphere through the centers using a cyclotron? Woo!
I mean, it's complicated because Daniel Nunes said you can't hook up 2 coils in series or else the resonance from one will just destroy the next one. So you'd have to do it with the pickup method.
Interesting.
Yeah.
Cyclotron.
Yeah. So if you're building and testing rodent coils, keep that in mind. You cannot apparently you can't hook them up in series, or you'll blow out the second coil.
So you can build them in parallel, hook them up in parallel, but not
series.
Yeah,
that probably makes more sense.
Okay. Good to know.
But I'm assuming the pickup method, if you're interested in at least what I'm doing with energy generation and stuff like that, the pickup method is probably ideal for energy, just because you're wasting all that energy, that extra energy is being generated in the center. That's ether energy. It's not going it's not just following the conductor, it's going everywhere. So the more pickups you have for it, the more you increase the efficiency of your system.
Yeah, I'm surprised that the pickups don't slow the rodent down. I'd love to see a video on that.
Well, I'm honestly, when I get that running, I will be doing more testing on efficiency. Michael has been doing awesome work there. If I can get him on maybe a pre-recorded video, we'll do some videos that way. For sure, I've been meaning to. He's just, he's a busy guy and he's in a different time zone, so it's a little difficult. But we will have updates on that front very soon.
Sounds good. Sounds good. Can't wait.
Yeah. Yeah. And again, shout out to Michael. He's doing some amazing work.
Yeah.
I just want to give you guys an update as well. Work Drive Tech, Todd's Destiano. I don't want to say his name wrong. Todd's paper, he sent it to me. I'm reading over it. I'm going through the math right now. Okay. I should be done here in about a week because it's a lot of references in there to different things. So you have to go back and forth in it. I've read it 2 times already. So I'm trying to work on it. But as soon as we do, we're going to have him on as well. And I think that's just going to be absolutely brilliant.
Awesome. What do you think of it so far? Like any spoilers?
His system seems to work the one we tested it. I don't have any question about that. Like I said, I wanted to check the math to see exactly where he was going with it, because there's talk and then there's math, and they both talk 2 different languages. I just want to make sure that we're both 100% on it. You know what I mean? So
awesome. Yes.
That way, when I ask him questions, I don't look like a fool.
No, yeah, exactly. But yeah, you also want to double check math, obviously, because people make mistakes sometimes, and it's very easy to do, especially with me with math.
Yeah, definitely.
But yeah, that's why we get peer review. We get somebody to get our back.
Well, if nothing else, he gets to get out what his system is. You know what I mean? And we get to ask him intelligent questions about it. So I'm happy about that.
Yeah, it sounds exciting. I'm always excited to have new people on the show for this podcast. It's been really awesome to see all the new technology and the new ideas. Hey, Mike.
Hey, Mike, what's up?
How's it going?
Doing great.
Yeah, it's going good.
Yep.
Hey, Nathan.
Busy.
Sorry, Mike.
Oh, go ahead.
Mr. Lanius is sending you and me, Nathan, a relaxation sawtooth oscillator. Have you received it yet?
No, I haven't.
Okay. Sorry, Mike.
It's okay. No problem. Just been busy this week working on Power Cell. So.
Yeah. Any updates on that?
Yeah, we finalized on the stuff that goes inside. And now I'm trying to master the construction of the device.
Oh, the housing?
Yeah, the housing for the device, yeah.
Yeah, you want it to be something that you could just set and forget, right?
Pretty much, yeah. And it'll run, I'm predicting this cell should last minimum 5 years or better.
That's so cool.
Nice.
That's so cool.
Yeah. Current is well over 2 amps per cell. But some tests we were getting up as high as, well, my partner, he got one test done and he got 80 amps out of one
Really?
cell.
Wow.
So your cell is exactly the mobile platform we would need to explore other planets,
Yeah, because without the energy, you're not going anywhere.
That's right.
Yeah. So you take this little battery cell with you and it's good for 5 years. That's awesome.
Years, maybe longer. We're Michael Kant's, before he passed, his cells were excessive 5 years. So they could be maybe still working today for all I know.
Yeah. Yeah. Maybe you just after 6 years, you just got to smack it a little bit.
No, it really has to do with the sacrificial cathode. If you come up with a method of protecting the sacrificial cathode from degradation, it could last years, 20 years, 30 years.
But that's exciting news because that's a big roadblock, and if we want to explore our solar system, that's where we're going to get the energy for long-term
Honestly,
travel and colonization.
yeah, honestly, it really kind of baffles my mind that nobody has come up with a method of stopping the oxidation of the sacrificial cathode.
Well, you guys did, and that's the important thing. We're seeing it now, and it's
Yeah.
awesome.
Yeah, like I like to show more, but because of the NDA, I can't do anything.
Well,
right
we'll see
now.
it eventually, when it comes out, when it's official rollout or whatever.
Yeah, we have some cool ideas how we're going to deploy it in a way that's not going to be too in the face of the media.
Oh, too
Because,
loud. Yeah.
Yeah, we have to keep it very low key. How we're going to do it. Certain industries we're going to creep it into, and eventually it'll make its way out there. So, yeah, like right now, the biggest hurdle right now is getting materials because of the big uh, port strike that's going on with all the shipments coming into Eastern Canada.
Right.
That's going to really screw up our supply chains. We're going to have a supply chain problem again, not just for electronic stuff, but for food and
I
all
know you
commodities.
said you were having problems sourcing some of the material, and that's going to put another roadblock in there, huh?
Well, there is one company that has the graphite that we need. It's in Philadelphia. So my partner is probably, he hasn't finalized it, but maybe in the next few months, he's going to take a trip out to Philadelphia and buy some. So if we get the proper graphite, like we are using a good graphite right now, but the problem is it's flexible, and we need the graphite to be hard. The type we need is called graphite ingot. So graphite ingot, it's almost like a ceramic, but it's pure graphite, and it reacts, very well with the cell.
Is its rigidness just dependent on how pure it is?
No, it's the way they fuse it during the fusing process. They use a special binder, and they put it around, I believe it's about 10 tons of pressure. So it's super compressed. The more compressed, the more compressed you make graphite, the structure becomes a lot more uniform. So when it comes to conductivity, it enhances the conductivity greatly when it's compressed at that pressure rate. So they do it with pressure and also heat. So you're creating a nano crystalline structure, and like the internal resistance. I have to hook my stuff up to this oscilloscope to see what the internal resistance of the cell is, but my hunch is it's very, very low, and that's a good thing.
Yeah, like my coil is like 8 ohms for that big coil. That's pretty good, right?
Yeah, if I can get mine under 1 ohm, yeah.
Yeah, that'd be pretty good. And that helps facilitate the output more, the voltage.
Oh, of course, and the current makes a hell of a difference. Yeah, most definitely. A lot of the cells I've worked on, they were putting out over 14 amps. So it's huge amounts of current. But now you got all the current in the world. You have to construct it to control that power. Because, you throw 14 amps into a circuit, the circuit's not going to like it too well.
We know all about that. Right, gentlemen?
Yeah.
So you have to control that potential. It's great to have it, but if you can't control it, then it's going to do more harm than good in the end, right?
It's going to cost you more money too.
Yeah. Right, circuits. But the thing is too, like what ours is more of a solid state call it a battery, because it really isn't. It's almost, put it to you this way: what we've built, my partner actually bought a Geiger counter.
Mm-hmm.
So he's going to construct a few test cells and put the Geiger counter beside it and see if there's any reactions going on.
Well, hopefully there's none.
Yeah, hopefully it don't.
Well, but if there is, it's going to be very small, very minimal. But it will prove a lot of the science what we've been working on. The quantum tunneling, Casimir, all that stuff, it's real.
Just remember, I like to remind anybody who's working on this experimental exotic energy, anything like that, treat it like nuclear material: time, distance, and exposure, right? You want to be very minimal until you know exactly what's, going on. I don't spend too long of the time spinning up my coil, like I don't leave it on for hours. Obviously
Right.
I'll have extended periods, but you got to be careful.
Yeah, anything with high voltage, anything with high voltage will give off radiation, period. Like, or the second we walk out the door, we're getting bombarded by cell phone towers that are 1,000 times higher output than what is legally allowed. And Eric Dollar pretty much proved this. You might as well just go and stand on the front of an aircraft carrier and have the minesweeper just go right through your body, because that's what it is right now.
Right, and the sun puts out radiation too.
Sure, we're inundated by cosmic radiation.
Hey, Victor. Nice to see you.
Rick.
Yeah, finally got it fixed.
Nice.
Hey, Mike's mic cut out.
Yeah, I was wondering, can you send Mike my email and stuff? I'd kind of like to get a hold of him and ask him a couple questions.
Mike Faraday?
Yeah. I
Yeah,
just
okay.
don't want to use the wrong language out here, since he's got an NDA and all, but I got a couple questions about it.
Yeah, absolutely.
I don't want to reveal something if I'm on the right track. So.
Oh, that's understandable. We don't want to get him in trouble.
That article Shawn was talking about, you can rotate and increase your magnetic field. Did you guys see that article?
I didn't see the article. Did you?
Oh, well, if I'm not interrupting Mike and all, I'll show you a little something real quick.
Yeah.
Yeah, go ahead.
Yeah, he had to probably restart because his mic was glitching.
Okay. So do you see that?
Yep.
Oh, can you actually? I guess I don't see it in there. Oh, okay, there it is. Yeah. Can I zoom in on that? That isn't zooming, is it? Oh.
We can see it though. So you got basically iron ferrite cores, and they're C-shaped, and they're going to the inner core of the bottom one, and then the upper one, they have a rotating, I guess it's a piece of metal, just says cylinder rotor.
There's an aluminum cylinder with a motor speed controller circuit on the right. They've just got a gapped ferrite core. They did this experiment first with sound waves, and it amplified. So they went in and thought, well, let's see if we can do it with electromagnetism. So this drum is just spinning inside the magnetic flux there. And it says when it gets past a certain... Why isn't it letting me move it? Can you still see the screen? It's called the Zeldovich effect, something they thought to be incredibly difficult. It's a simplified induction generator, and they think it's fundamental in nature. But anyway, the cylinder has to rotate twice as fast. Okay, the amplification only occurs in a specific condition. The object rotating at an angular velocity that's higher than the frequency of the incoming waves divided by the angular momentum number. And here the number was 1 due to spin angular momentum, but it can be larger. They tested it in sound waves and then proved it in electricity. So
Nice.
it destroys one field and wraps it around and sums the two. When the cylinder rotates faster than the field frequency, it thus amplifies the spin component rotating in the same direction. So the cylinder acts as a resistor.
That makes sense if it's aluminum.
I'll be
I thought
honest,
that
I'm
was-
going to have to go over this a little bit more. It might take me a couple of readings to understand what's going on fully, but this is really cool.
Yeah, I put that link in the. I put it in the link, and then when Straight Dope's on, I want to talk about this here new spin liquid for magnetism, and possibly this new superconductor that has record-breaking current density. And if you notice, it looks like a pituitary. I mean, not the pituitary gland, the pineal gland. It's a pine cone shape. Anyway,
Nice.
that was just a couple of things I had to point out. And then I had one thing on the Graviflyer. I don't know if that is something you want to look at real quick.
Go for it.
Yeah, I'm down. Always down for the grab a flyer. I was trying to think of a quick snippet there, but I couldn't in time.
Okay, we use standing waves, right?
You'd have to ask Nathan. He's the resident expert on the Graviflyer. I'm not too sure.
There are standing waves in the. Well, this is about partial standing waves.
Okay.
Can you see it?
There we go. Go ahead.
I've never heard of that before.
Okay, this is using Wolfram. If I can get it to respond. Okay. This, can you see there's a forward wave amplitude in blue. His amplitude is at 1 amp or 1 unit. Then there's a backwards traveling wave with a half amplitude. And so over time, we can play this and watch the partial standing wave. And I don't know if you can see the magnetic vector down here. Why did it stop? It's rotating like a lighthouse down here. See that black arrow?
I see it.
So I'm wondering if the two plates on the Graviflyer, when they're rotating, if we need a forward wave to be twice as much as the backward wave. And then we get this rotating lighthouse-like magnetic field going around it on the center plate. I don't know. That was just something I noticed when I was looking at this format of standing waves. Because I had never seen that.
So the ratio is important, maybe.
Well, the two speeds, yeah.
Huh.
So I don't know if that helps, but you can download, if you go to Wolfram, you can download a player that allows you to open up all these scientific things that people are doing. And I've got, I don't know, hundreds of them. People will post their experiments, capacitors, induction coils, anything you can think of, waveforms, the whole bit, stuff like Fractal Woman does and what you just saw. You can download all those little things and play with them and tweak them and learn from them and then apply it. If you want to, get some research ideas that you can't afford or whatever, there's tons of these. I don't know. I could show a lot of them like that anyway. But that one for the Graviflyer, I thought might be applicable to our speeds, the two speed differences?
Well, there is two standing waves that show up,
Two.
and yeah, there's just the top and the bottom one like you showed, but they on the oscilloscope they cross, so they are crossing each other, so they're 180 out of each
Right.
other.
Those seem to have an odd phase where they were. So I'm not
Basically,
sure how they're doing.
they're making packets so that you can put something in the packet like you would an amplifier. Okay, how you have the top around and the bottom round, and in the center you can put the information. So they're coming out with those, and then also there's 3 rings that come out of it. Okay, so Tesla coil rings, and it's because of all the bad insulation wires that it takes on a uniform frequency on everything. So even though you get all these different waveforms in there, the whole craft has a uniform frequency. So
Right.
it rings all the same. But those 2 standing waves are still there. So, and it doesn't start to pick up the correct energy in it and start the angular momentum until you start picking up that energy. So as soon as you do, it starts to do this.
Oscillate sort of. Yeah,
Yep.
I'm waiting to see your energy buildup that you're going to present later.
Yeah. Well, it's all going to come out here in the next few months. I'm working on all of it. It's kind of going to be an all-in-one dump. You know what I mean?
Cool.
So,
Well, I'm still reading on John Mackin's paper. I printed it out in plastic. My mom put covers over the pages for me, so I'll have it forever. And I've got a laptop with Wolfram Mathematica on it, dedicated for that now. There's something in his paper. You guys, I wish Gerald was here because there's connections to things that he has made in that paper that are beyond just the paper itself, proving ether. Connections to other things. One of them that surprised me, if you read it, it's towards I think page 25. There's a ratio in there, 43,200, 432. There's a component in that paper. We need to.
Oh my God. I watched a video today that had everything to do with 432, how they divide and everything and how they make it work. I also watched a video on not putting the 0 before the 1 when you do your math so that everything starts to work out and create all of the rodent coils geometries that's correct. So I can send those 2 videos to you. They're absolutely amazing.
Anything, yeah. Because the more I learn, then the more I can see where points I have could be shared to where we can all jump on. Because I've spent months in that Mathematica before I bought it, or got it given to me actually. Yeah. So I told Fractal Woman about it. She said, cool, keep her apprised. So that's just one of the points I noticed was the 432. And there's 2 other points that I want to pursue, but I don't want to drop it right now because I kind of want to make a presentation.
Nice. Yeah, that 432, man, it's a special number. And what I was trying to say was when we create the geometries in this coil, you're going to get natural resonance frequencies throughout the whole thing. So you're going to actually pull off there's like a field, there's a sound thing in there, you know what I mean, with the frequency that goes on, and you're getting sound because the thing pumps like this. Remember the pump? Because the vortex is pumped like this, you're getting a speaker effect. So you're getting the sound that comes out of them. So you get the frequency in the coil, you get the sound because of the pump. So it all ties together.
Mm-hmm. Well, when I read John Mackin's paper, the thing that tripped me when I got to that page was I remember, I think it's a guy named Hancock, I think. He's doing all the pyramid stuff. He said that the pyramid of Khafre or whatever on the Giza Plateau is a 43,200 scale model of the Earth. That the scale is 43,200. When I saw that same number in his paper, you need to read it, dudes. It'll blow you away. I think we're on the right trail, but we're on the wrong vortex. We're looking at the electron, and the electron has an equal partner called the muon. So when the cow jumped over the moon, we need
looking out.
I need two muons.
That's mind blowing though. But that makes a lot of sense, Victor. Every time you explain it though, it makes more sense to me.
Well, the field coming out of the bottom is different than the field coming out of the top, isn't it?
Well, ground and discharge, yeah, they'd be different. Anyway, if you read the paper, I think you might see what I'm onto there.
Oh, trust me, I watched it. It has it in there.
Yeah, I got to watch him again twice because he says stuff that's not in the paper. So it's like I want to watch him again while looking at the paper, and then I'm going to add notes, and then
there you go.
But that's mine for the moment. I'll step out unless somebody wants to see something else or ask a question.
Well, once you know where things belong, connecting the dots becomes easy. If you can place everything in the right place, right? Then people who do the math can do the math on it, and they can find all, like you're doing, all the fractals and everything in it, right? We can also sit there and do all the field research and find all the fields in this thing, exactly which way they're moving and how fast, right? We can find the frequencies in it. Then we can find all the sound waves. Now we can find the particular energies that come out because you're north and south and you're pumping it. So it's all right there. You just had to know which order to put it in and which one starts before the next one and what's the effect. Which one's the cause, which one's the effect.
Yeah, the article about just spinning a cylinder of metal, increasing the magnetic field, just kind of reminded me of something, some type of propulsion where it amplifies the magnetic field constantly just through motion. It fascinates me because it's all moving parts. It's not so much electronics or circuits. So when you're talking about moving disks and magnetic fields, electric charge, electrostatic fields, it seemed to coincide with that experiment that we just read about.
Yeah, and I just saw one yesterday where Aaron Murakami was showing his presentation of a homopolar motor where they take two magnets and stick them right on the plate and then tap it and get AC off the shaft and the edge of the plate. And that's not supposed to happen. So I was thinking, wow, there's different aspects that we need to mix and incorporate.
Yes.
So much to it.
Was that the Linderman video?
No, it was just Aaron. It was from Russia. Most of the comments were in Russian, so they were watching it and commenting on it. But
yeah, the title of the video.
His version after Lindemann and the Borderlands video.
How could I look it up?
I'll try to find. I just watched it the other day. Maybe I can grab the link.
Yeah, if you have the link, throw it in the description. Go ahead, Shawn.
I love the name homopolar motor. It's just fun to say. You got your homopolar motor? Sure.
Oh.
What do you call me, boy?
See?
What now?
That's Ben's middle name.
Oh man.
We'll take kindly to your talk now.
Oh. He's one in the basement. Oh.
It's in the
Love it.
closet.
Oh my goodness.
Oh, always good fun, man. Always good fun. Oh,
Okay, that should be it. Whoa, what just happened?
like you said, you put it out to everybody. That's
Oh, good.
Yeah, it's called the N machine, I guess. Homopolar generator.
Thank you, Victor.
Thanks for your presentation. I really love your that Death Star one. I swear it just looks like something Wile E. Coyote has waiting for the Roadrunner, and the fuse is lit.
Yeah, it does.
Thank you.
I swear.
Thank you. Yeah.
It's
now Bruce
always
De
lit.
Palma. He came out with mercury on his.
I don't know if I know how to make an algorithm. I guess it's just a recipe, right?
Yeah, it's just a line of code that you do an input and it has an output.
Oh, maybe that's how I do my math, because I do go through a certain pattern of different keys on the calculator when I'm. Is that an algorithm?
I'm pretty sure. Maybe not technically. I don't know. Sounds like one to me.
Bruce D.
I try to
Palma.
help 3D Havoc if I can. Yeah. Bone size 618 Gmail.
Oh, Bruce De Palma.
De Palma, yeah. I think I met him years ago, but
Yeah, he's got the machine that he did the homopolar generator in the center, and then I think he used mercury as pickups on the outside of it. In one of them.
Huh.
Yeah, it was pretty cool. We were watching that on Bernie's channel, or no, we were doing this. I don't know which one it was. We were watching it with Bernie though.
We've done so many. We do so many of these friggin' podcasts. I lose track myself.
Oh,
Information overload sometimes.
It really is. Like I kind of need a day or two sometimes to process.
I had to sleep all day Sunday and part of Monday. I was getting exhausted.
Mm.
Yeah.
I mean, that hurricane now and the stuff that's going on, that is unreal. I'm just going, oh my God, did my big mouth help them figure something out?
I haven't checked the news in 3 years, and I've never been happier.
Oh, yeah.
yeah, I bet.
No blue light for you.
Yeah. I got my bug out bag in the car, and I got a house in the woods. I'm set.
Cool. Well, I may fly over your backyard one day and ask for a cot.
Yeah, no kidding.
My pleasure. Anytime.
All right, guys, I got something for you. I did an intro video. Bernie was asking for a year of the coil thing. So let me know what you think about it. It's not a spoof. It's not funny, okay? It's just something interesting. So.
We live in an age of lost knowledge. We were shown the way by our forefathers, yet we are blinded to it now. We believe what we are told instead of researching it for ourselves. Thankfully, there are those who will not just follow blindly. Legends like Tesla, Steinmetz, Faraday, and researchers like Marco Rodin, Eric Dollard, and Russ Gries have brought true understanding back to our world. For far too long, we have anguished in theory instead of experiments. But the researchers today have brought everything full circle. They use ancient symbols and mandalas to build coils that give us back our long-lost knowledge. Frequency, resonance, and cold energy are their tools. No longer will we be satisfied waiting in the shadows for scientists to stumble upon what we already know to be true. It is now up to us to restore our world to balance, then go beyond it. We are truly in the year of the coil.
Oh yeah, year of the coil. It
So what
is.
do you-
And
Wow.
what a year it has been.
Well done.
Oh,
Yeah,
thank you.
I like it. And the year of the coil, it just has a ring to it. And it kind of summarizes everything that's going on this year.
Very
Yeah,
cool.
but-
You put that together?
Yeah, Bernie was asking for it. So I don't know if it's what he wanted, but that's what I did. And then I'll show you real quick. I have a little symbol for him as well. Look up in the right-hand corner. I just switched it over. So
Nice.
there's a little coil one up there.
It's a rodent.
Yeah, a little rodent coil, a little energy around it. So
And it's in Ben's corner.
yeah, that's right. You got lucky on that one.
Yeah.
And
Anyway,
I'm
that-
right to bed.
Well
just
done,
wanted to
Nathan.
Thank you very much. I just wanted to share that because, like I said, Bernie was asking for it, so I went in and put it together. So let's see if he wants to
Awesome.
make any changes. But they said Rodan, I think it was, instead of Rodin. So we have to change the guy's name.
Yeah, sometimes you gotta play with it, but no, it's good. Thank you for presenting that.
Yeah, I was going in fast forward like half the time. So it would say one sentence real slow, and then the next one was in fast forward, and I started getting crazy on my computer. Like, what the is going on here? Why can't you just say the word? So I had to take out half the wording and just let him say that little part so he could say it slow. That's AI for you.
I love how Ben was swimming in a sea of rodent coils.
That's right.
Very cool. Nice work. I like Year of the Coil. I like it a lot.
Right on. Well, that's what we're working on, aren't we? Everybody's kind of working towards the same goal.
hmm
And it's kind of the whole thing here. So
Yeah, and coils are all about geometry, magnetism. They're all encompassing too. Coils are a one-stop shop for many scientific discoveries, as we're finding out.
And they're very, 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 very fun to make.
Oh yeah, I love winding them.
Yeah, me too. That's one of the funnest aspects in the different ways to wind them.
So-
Exactly.
check this out on any coil. Okay. We're going to have to start seeing, you obviously know if it's a donut ship, right? You got a field. Okay. Now, what we're going to have to start to distinguish is the frequency, how it lays out. Is it bent slightly like this, like you would see the seed of life? Okay. Then you're going to also have to figure out which one's the sound wave. So we know the sound comes up like this, right? So how exactly are you putting that into a field? So when you start talking dimensional geometry on this thing, you're going to have to identify those. I guarantee you when we're done identifying it, we are going to pick up a picture of a mandala and never look at it the same again. Everything was defined way back when. We're just relearning it.
You know, I still watch that Mandala. Is that how you pronounce it? That short that you put out, and that still blows my mind. I watch it every now and then.
Crazy, huh?
Yeah, I mean, it makes sense though. It really does. Like, and even dream catchers, you know, the patterns that they have. You know, and maybe they weren't fully aware of it. Maybe they were trying to replicate something that their ancient ancestors knew more fully. Who knows?
Well, everything's a pattern. Just realize that right now. Everything is a pattern that keeps repeating itself for a reason. Whether it's in that number or double that number or divided by that number, it's still a pattern. Okay? That's exactly the way everything works in nature. So I was telling Shawn, he's over there making fractals, right? When he puts this thing inside the tube. Well, what happens when you take a sphere and put it on top of the sphere you got? Are we going to get fractals everywhere on it? If we do get fractals everywhere on it, then are we 3D printing basically seashells in the middle of the ocean based on that fractal pattern growing with the stuff in the earth itself? Okay. That's something that's pretty interesting to find out. If you have a sphere that's acting like a magnetosphere, you have to test it for the fractal pattern on the outside. So putting a shell around it that can actually get those fractal patterns from the energy discharge. Let's see where we're at.
You know, Nathan, that reminds me of an article I read about the Fibonacci numbers and the golden ratio spiral. They were saying that because the Earth is round and electromagnetism is a planar effect that's at 90 degrees, it causes a stress trying to be on the rounded surface. So it buckles and gives us three-dimensional, because the fractal set is actually the Mandelbrot set is a two-dimensional plane, and it's been found that if you added just one pixel or particle to it, it would pop into the third-dimensional plane. So it's possible that we are actually an expression of a stress factor or something. It's weird, but anyway, it all comes about from stress on the surface.
Right, tension or
His thick fibrous, Shawn's fibrous tendrils. I think that sphere is helping it.
Yeah, it's creating a cavity in the center, right?
So I mean in the discharge fibers where they're thick and fibrous.
Yeah.
Because Tesla said that they thought electricity might reach out longitudinally, like you'd start out, the wave would go at you this way instead of trying to do that.
Yeah.
It would just longitudinally pop right out.
And that force is instantaneous from one point to the
other.
other.
And that's like a fiber, a tubule. I don't know if you can. Anyway, that is a tube
on the sphere. You can see it.
Yeah.
That was a neat looking device. I was wondering what that was.
One of my thought models I play with when I'm doing things.
Mm-hmm.
Well, it's funny because energy travels on the outside of the wire. So when you show that, it gives you a better understanding of how energy gets pinched and you create heat. And then it unpinches and you let it go back to its natural form on the outside, and that pinch goes away, right? So you can see why there's heavier amps in at that time when you pinch it, because you're blocking everything else and you're throwing your voltage into it. So it's clamping onto it. So it makes a heck of a lot more sense.
I freeze frame some shots that are interesting on the sphere. If you want me to present them real quick, I'd love to get the group's opinion on them. I didn't share them in the presentation, if you have a minute.
Yeah, absolutely. Hey, just real quick, I wanted to talk about this. Shawn has the negative coming out the bottom, right? So he has the ground coming out the bottom. He has the discharge coming out the top. So he's naturally creating a north and south pole in this thing. When he showed the energy pulling into the coil itself through the ground, you could see the energy flow pattern going on. He's got way more going on there than what you think.
Yeah, I agree.
He's also using 3 holes. I'm kidding.
My goodness.
Oh, man. Is one hole bigger than the other?
I don't know if I have the right screen open.
Oh, it's so great.
You close
Yeah,
that.
sometimes you gotta close it out and reopen it.
Yeah. Let's try
Here we go,
again.
Victor. Here's a question for you while we're waiting. The golden ratio is broken down into quadrants: 1/5 magnitude charge part cycle, 1, 1, 2, 3, 5, where the first one is used, but by the 1, 2, 3, 5 is used for the 4 quadrants.
So it's a quadrature, but the changes are in fifths? Huh.
So how do I share from here?
90 each time.
Nathan,
Okay,
I
hold on.
selected.
I'm putting it up right now.
Okay. These are just screenshots, so I have like a YouTube in the corner playing. But I'll show you these. I was trying to freeze frame the tendrils from the sphere.
Are you
So-
trying to like create the album art for my next album right here? This is so hardcore. This is awesome. This is like we need like a guitar on the front of this right here.
Yeah,
Can you guys see it?
yeah.
So I was trying to capture it in different directions to see if you can see the twisting that you mentioned, Nathan.
Yes.
But this one seems to be having like the tendrils, like Victor was saying. Here's more
It's so
tendrils.
vibrant.
Yeah,
Like and it's very intense at the bottom. You see like those little tiny intense bits at the very bottom, and then you kind of see like a fog of light pink following it. It's very, very awesome. Like it almost looks like art. I mean, it is art.
Yeah, I appreciate that. Thank you. It's the hot rod. It's the 4 Mosfet ZVS that makes it real thick and white at the bottom because it has a lot more current.
Oh yeah, it's a really nice shot right there. So that how many volts is going into that thing right now when you took that shot?
You're seeing about, this is 90 volts.
Mhm.
Maybe up to 100 volts AC. This is when it goes silent. Nathan, do you remember that?
Yes.
It right after about 75, 80 volts, it sounds a bit loud, and then it goes completely silent for the next 30 volts. And this is part of the silent volts, if you will.
So it's like a range. You get different effects at different ranges, or it's like it comes and goes depending on
Like
the
frequency
voltage.
ranges. Yeah, frequency
Yeah.
range. Yes.
Wizard has a good point there about overtones. Do you know that video I sent you guys with Aaron Murakami? He's got another one where the Borderlands one. Eric Dollar was in the background saying that there's 3 overtones, and one is a power overtone, and the third overtone is where you're actually getting energy back into the system. And he goes, that is hard for us to reach. And Wizard says you've got overtones there thickening the plasma. So I'm wondering if you're actually reaching the 3 overtones where you're getting not just discharge and power, but then bringing the energy back in or something. I'd have to watch Eric again, but I wonder if the overtones are a point.
I mean, I should try to find it, but that video I shared where it was pulling electrons straight from the earth and just putting them straight out. And I think it was Mr. Lania said that there's some augmented effects around the sphere. And we talked about how the electromagnetic field around the equator is almost unmeasurable, but it's super intense at the poles. And I just think all of these geometries working together, you're getting some kind of force that's pulling from the earth and pushing into the atmosphere. And the twirls in that, I don't get the swirls. It's like it's drilling through the atmosphere. This one is on where I change from the 60 to 70 volts. You'll see the skinny tendrils behind and then larger in the front. I was trying to catch it the right time because there'll be an entire skinny tree behind it, and then there'll be this tendril thick tree in the front. And I'll see if I can capture it because it's 2 trees. But this is me trying to catch it. I think I was looking for oh wait, yeah. So this one again is the hot rod, the 4 MOSFET. So a lot more current. I was trying to see if I can drill into that bright center. And this is it. 30 seconds of just it in action. always mesmerizing to me. I don't know if there's Tesla coils like this, to be honest.
No, there's not. That's yours.
Yeah, when Nathan brought you on, he assured me, he's like, dude, there's nothing like this on YouTube. I've not seen this at all. And Nathan would know.
Sorry.
I've never seen anything like it. This is extraordinary stuff. Like, you know, when you see the cool popular Tesla coil videos on YouTube, they're just like messing with sound, you know, or putting music to it or making the sparks big and dance to music. Like just a stupid old, like, you know, song and dance. They're not, you know, actually messing with the Tesla coil in this way.
Right. That's so true. I don't want to insult others because it's not easy what they do, but they all look the same. And
yeah, I'm not
know.
saying it's easy or anything. Yeah, I'm just saying it's just the same old thing, and it's kind of boring to me. Like I've seen it once, it was cool, you know, but let's move on to the next cool thing, you know?
Right, exactly. And yeah, I love the feedback too, hearing guys people's opinions on what they're seeing. I appreciate that.
Yeah, you really pushing the bar here. That's the whole point, is you're pushing the bar and nobody else is. Nobody's pushing against that bar like you.
They want a pyramid, Shawn.
Yeah, a pyramid coil. Oh my god, that would be awesome.
Who's they? Everybody?
The people. Yeah, the people have spoken.
Yeah.
All right, it's on my list. My good list.
What's up, Mike? You look like you were falling asleep.
It's been a long day. I've been doing a lot of overtime plus working on the power cells. I'm just like it's catching up to me.
Yeah.
So, but we got a long weekend coming up here soon. This weekend
Hopefully you catch a break.
Yeah, well, we got a 3-day weekend this weekend. It's the Canadian Thanksgiving, so.
Oh, that's nice.
Yeah, so we got Saturday, Sunday, and Monday off. So.
You guys eat turkey on Thanksgiving too?
You know what? Our family, you know, my wife's Filipino, so we do potluck. So everybody brings something. So
that's nice.
It's an amazing variety of food. You know,
yeah, it's different every time.
Yeah, like my wife's aunt, she's Filipino too, and she makes an amazing lasagna, like amazing. So, you know, we have a good mix of stuff. Yeah, there'll be turkey, but it's not the main dish, you know. So, yeah, it's always there's something there for everybody, right? So, always
variety is the spice of life. That's what I say.
Oh yeah, for sure. Especially Filipinos when they have a party, they go all out on the food. Definitely all out. So,
but that sounds like fun.
Yeah, so I'm trying to fast for the weekend.
He's preparing. I like it.
Yeah. So, yeah, but I just been working overtime, really working on the cell because it's like I want to get it done, and you know, you make one little discovery or one little change in the configuration, and then you have to evaluate your other stuff that you've done, and you know, you're always cross-referencing everything that you've done. So it always turns out one of my very first test cells were actually the cell that I'm going back to in the construction. So it's like you have to try all different possibilities, all different ideas, try it out, experiment, because there could be one lesson learned from that that's invaluable, right?
Yeah.
So, right.
Try it out before you fry it out.
Yeah, you have to try every kind of possible scenario, every kind of configuration. You have to go step by step. You know, 9 times out of 10, it's probably going to be a failure. But you learn something very, very important about what you made, what you did wrong.
Exactly.
So now you know your limitations. How far can you actually go?
Yeah. Right? When I was doing the rodent coil, you know, I didn't immediately get the results I was looking for. So I tried every possible configuration of the wires that I could think of. You know, I tried asymmetry for the coil even, and you know, I finally got it, but you know, it was that trial and error process.
The same, the same with my Renegade device. I've been working on that for like 7+ years to get to the design that I'm at, because I tried every possible scenario, right?
Yeah.
Every possible
Yeah,
connection.
you have to be sure. You have to be sure.
Yeah. But, I'm the type that I have to see the failures for me to actually get something out of it.
Yeah, because
So,
that also tells you what your thresholds are, or your barriers are too. You know, your
well,
limitations.
to the average person, a failure is a failure. Actually, no, to me, a failure is a win,
Well, I'm
because
talking about in the
learning
system.
something.
Like, say
Yeah,
you fail at making something work in your system. You know, that might tell you a limitation of the system. You know what I mean?
exactly. So you're getting something out of it. So that what you
Yeah.
thought was a failure is actually not a failure. It's a
Right.
confirmation. It's a confirmation to say, okay, you can't go that far. You got to go a different direction, or you got to back off.
Exactly.
Right. So, yeah, I look at failures a totally different way than the average person. You guys are probably think on the same lines, the way I think. A failure is not a failure. A failure is something that you've learned limitations, or go in a different direction, or back off, stuff like that, right?
Right.
So,
It tells you something. You know,
yeah.
you always learn something. But
That's right.
So going back to your cell, how many months do you think, or years, before this thing is, you know, fully operational?
Well, I'm hoping by the end of this year we'll have a completed cell the way we want to make it done.
Mhm.
So we got
Oh,
a
for
couple of weeks to
replication.
go. Right.
Mm.
Because we have people that are interested in it, and that's a whole other different, story all on its own, on how we're going to start deploying it, like do beta testing and stuff like that. Uh,
Mm.
One of the beta tests that we want to do is run a refrigerator nonstop.
Right.
So
That's
we've
a good goal too, because refrigerators
yeah.
are heavy.
Well, if you get the right, you know, I have a GE, and it
Mm.
only pulls 1.1 amp at 120 volts. So it's only 180 watts to run it. So that's a very efficient refrigerator, and it's full size. It's not a small refrigerator, it's a standard full size refrigerator, but it's a very efficient one. And that's good. That's actually a good model to test with. So we've ordered our battery bank. Um, they're the Power Queen, 12.8 volt, 100 amp hours. So
Mm.
we ordered 4 of those, and that's going to run a 4 kilowatt inverter. So the refrigerator is going to run off this system, and our power cell technology is going to keep those batteries charged. That's the plan.
And how much amperage did you say the refrigerator gets or needs?
It only takes 1.1 amp. I was surprised. I
Oh
looked at the
wow.
manufacturer's
Mm.
sticker. Yeah, it's very
Yeah,
efficient. Very
that's
efficient. I was
awesome.
like, what? Only 1.1 amp? It's like, wow. I was really surprised. I was thinking, 3, 4, 6 amps, something
Mm.
like that. But I looked at the manufacturer's sticker, and it's 120 volts AC at 1.1 amp.
Mm.
So I'm like, cool. So now we know what to look for. We're actually going to purchase a fridge and actually use that for our beta test. So
Yeah,
that's
just
the
hook it
one
up
we're,
and run it. That's awesome.
yeah, and just run it, right? So we figure 4 Power Queens, they're 112.8 volts at 100 amp hours each. So
Mm.
we'll hook up the 4 batteries up to the 4 kilowatt inverter, which is a decent power plant to run, our setup. So we have to we're figuring about 20 cells are going to take to run this. So it's a lot of work and quite a bit of investment to build these 20 cells. But when we get it all done and up and running, I'm going to have a full, management system. It's going to be I'm going to use a Raspberry Pi with a touch screen. It's going to have all the software so you can monitor all the voltage and amperage and the full battery monitoring. So we're thinking about using maybe those stand-up server cases that you can buy. They got a nice door on it, glass, and it's got all the shelves. So we're thinking about actually building the unit in one of these. I believe they're about $500, and they're about 4 feet tall. Cabinet, glass fronts, got a lock on it, and everything looks really professional looking. And put our whole setup in that. So, and it's going to be on wheels. So
Nice. Maybe put a couple of LEDs on it.
Well,
Or
yeah.
RGB.
Well, we probably will have some LED lighting in it too, so we can monitor stuff and also see inside too. We have to be able to see what's going on inside, all the components and switches, and we'll have protection on it. We'll have fuses.
Do you guys have like a cool logo you can stamp on it?
I've been thinking about, we're talking about maybe opening a company a little bit down the road. I do have an idea for the company name, but I don't want to say it.
Oh, no, that's fine.
I have to do a search on it to see if anyone's actually used that name. So
yeah, you got to double check and all that. But I was just curious.
Yeah, eventually I think it's going to lead to that if this takes off. So there's about 3 different industries that we want to deploy this in. So
yeah, pimp it out a little
bit. Yeah, but eventually it will make its way out there. This is going to put the whole battery industry upside down. It really is, because if you got a battery and you go to one of these conventions, they just had one. Where was it? I think it was Singapore. They had the battery convention. And could you imagine, you go to one of these conventions, you have a booth and say, oh, by the way, I have a battery here that doesn't need to be charged.
Everybody will be at your little booth.
Yeah, I'm gonna have this little 4x5 friggin' cubicle, and all these other people are gonna have like displays that are like $100,000. I'm gonna have this little cubicle about this big, and I'm going to say, oh, yeah, by the way, my batteries, they last 5 to 10 years and they don't need to be charged. Could you imagine?
Yeah, you're going to flock everybody. Everybody's going to flock to your little booth, and then you're going to need a bigger boat.
Yeah.
I want one.
And what's going to add insult to injury is we're all doing this on a shoestring budget. Look at some of these battery companies like CATI. Multi-billion-dollar corporations, and we got technology better than them.
Makes
you
wonder,
Cool.
And we're doing it on shoestring budget. Like, you put their best battery against mine will win.
That's awesome.
Hands down.
Yeah, knock them out of the park.
Not just in voltage, but in current. And the fact is, they don't need to be charged. They don't need a charger. They create power. It's not like a galvanic action where as soon as all the ions are used up inside the battery's ready for the trash can. Ours are not like that. Because nobody has solved the problem of the sacrificial cathode. If you make that cathode not oxidized, guess what? It's going to continue to let off ions. There's going to be ion transfer. And nobody's doing it. Nobody's saying it. I've seen 1,000 videos of these huge corporations working on this stuff. And not one of them, they're all like beating around the bush. It's like, okay, they all know what the problem is, but nobody has solved it.
Or they've solved it and don't want to release it, because if they do, they don't get all the money for the disposable batteries that they're banking.
That's right. It boils down to the money. So I'd be very surprised if these companies haven't solved it. If they haven't solved it, I would like, wow, really? Because it's not that hard to figure out.
Yeah, I hear you. Awesome. Good for you, Mike. I want one.
Yeah.
Yeah, me too. That's awesome.
I'll trade you for a motor that does things that will really help your system along. A little bit more than the Adams motor that you built, although it's a beautiful piece of machinery, Mike.
Hey guys, real quick, Shawn needs to say goodbye. He's
All right.
got to take off.
Hey guys, it was a real pleasure. I'm honored to be on your show, Nathan, and I'm honored to be part of such a group of smart people, and lots of love in the chats. Appreciate it. And I look forward to seeing you guys next Wednesday.
Right on.
Many
Thank you,
blessings,
Shawn.
Sean. Thank you.
Thanks,
All right.
Sean.
Take care. God bless.
Take care.
Bye.
Take care.
Gerald,
Yeah,
you made
and-
it.
Yeah, it's been a rough day. It's been a long day.
I hear you.
You guys don't want to hear about it. I just got back from the hospital. My brother had to have an emergency surgery, so I wasn't even gonna pop in. But you know what? My name's on the title, and I figured I don't want to get you in trouble for doing a video with my name on the title and not showing up, right? Not that you would, but you know, I got to make an appearance.
Yeah.
Sorry for
Right.
that, guys.
I hope he's okay, your brother.
Yeah, he's okay now. Touch and go in the beginning there. He was getting septic. The infection was so bad. So yeah, they had to go in and take out this abscess, and he's got to spend a couple days in the hospital and make sure that the septic, whatever, that poison gets out of his system. So
yeah, my mother's had some issues too, so she had to go to the doctors today, and she's gonna get some tests done. She battles with reflux disorder, so it's really taking a toll on her. Yeah, and she's 79 now, so she's not young anymore. So something like this is actually, it takes more out of you now that she's
at that age, I guess.
Yeah, so yeah, I'm blessed. My parents are still alive. My dad's like 83 and my mother's 79.
Wow.
So
Nice.
yeah, so it's like, you know what? It's like that day's gonna come. I know it's gonna come, but
For us all.
Yeah, and I'm just happy that they made it to their 80s. You know what I mean? So
Yeah.
That's right.
yeah,
I'd be happy to make it to my 60s, let alone my 80s.
well, I'm ahead of you. so
60's
don't
right
worry.
around the corner, man.
Dude, I didn't think I'd make it till I was 25. So what was that, Mike? Sorry.
Yeah, like I before it was like I was always the youngest one. Now I'm like always the oldest one. Like even at work too, I'm like one of the oldest guys there, and I'm like, really? Like some of the other guys, they look older than me, and they're like 5 years younger than me.
Wow.
And I'm only I'll be 52 next year, right? So it's like some of these guys, man, what the hell happened? It looked like you hit a wall.
Stress, man, stress, and people don't take care of themselves. That's why my brother had his issue. Didn't take care of himself. Not eating right, not working out. I get up every morning and I work out for at least 30 minutes before I even have my coffee.
Really?
Not because I want to. What's that?
Like I do such a physical job every day. It's like when I get home, my whole body hurts. Like it's like I've done an 8-9 hour workout, right?
No
I
doubt.
work on a water jet. I'm working with a crane. I'm lifting steel. I'm loading it in the machine, loading it back out. Some of the stuff that I'm lifting is like a half a ton. Some of it's over a ton, right?
Yep.
So,
but that
it's
doesn't
pretty-
mean you shouldn't work out and exercise. Exercise is
Yeah.
motion, right? It's not to get big or get strong, although it's definitely a bonus. But it's more just to keep your tendons nice and loose, and you keep your balance that way. Because what kills most people once they get into their old age, it's losing their balance, and they fall and they hit their head or their hip, or you know.
So if you see what I do on a daily basis, you'd be like, "Holy crap!"
Yeah.
You know?
Hey, no doubt, man. I understand. When I was like 10 years, maybe 20 years younger, I was a bull. I'd work 10-hour days and just be shoved.
That's right.
Yeah.
But as soon as you get into your 50s, no, you can't do that no more.
It's not worth it. Your time is so short. Why would
Yeah.
you break your body, right?
Yeah, like my hands are like, when I get home, my hands are like swollen.
Yeah.
So I'm using my hands to grab and hold things and
But
maneuver
then
the steel into it.
your hands are swollen. But now, if you didn't work for a couple days and you grabbed somebody and you went, you'd break it because your hands are probably like steel, right?
Yeah, my hands are like vice grips. Yeah.
Yeah. Yeah. That comes from working every day. I used to love swinging a hammer. I'd be doing the
He's got
comp-
balls of
stuff,
steel. I'm sorry, I play a lot of Duke Nukem.
So, Mike, could I ask a question about your cell?
Sure.
At present, if you guys say we're ready to go market, what kind of price range would a guy be looking at for one of these units?
It depends on how many kilowatts you want. So, like, say a 4 kilowatt system, you're looking at about right now, like from what I've seen, the industry standard for a 4 kilowatt system is about $1,000 a kilowatt, right? So, and
Nice.
the cell, you see, like the cell technology is kind of revolutionary. So, like, we're trying to keep the cell costs down to a respectable range, so we could have a 25% markup and make some money off it, right? But the graphite plates that we need for it are getting harder and harder and harder to get because the biggest manufacturer is in China, right? So trade with them is they've had their challenges, and now with all this border stuff at the shipping docks on the east coast in Canada, there's a strike going on, and that's going to disrupt supply chains. And it's just like certain components we've been after have been getting same, even like magnesium too is hard to get in the sizes that you want or the quantities that you want because China is the biggest producer of it. So that's the challenge. It's not putting it together, it's getting this stuff. That's the real challenge right now.
Yeah, the more we use it too, they might bring the price up then if they know that we're getting it.
Yeah.
I had a good site for solar panels. They were 520 watt solar panels bifacial, so they could produce up to 750 watts in total.
Oh.
So they were really nice panels. I was going to open a business on it. I built this trailer, but getting the panels now because they come from China, big pain in the butt, and they've almost doubled the price. So it's not even worth it. Yeah, it's not even worth it.
Speaking of solar panels, they've just created a see-through solar panel. It looks like a plane of glass.
I'm glad I didn't open a business then. I would have been shut down right then and there. That's awesome.
Looks like a plane of glass. New solar panel just came out.
Is that commercial, like for sale?
It's right now. It's I think it's still in the testing phase, but they showed it. It's kind of like a science breakthrough, right?
Nice.
So, that's the one where we can have windows that are solar panels?
Yeah.
Yeah.
That's cool.
Yeah, that would make it really incredible if you think for making your car windows solar panels, it now helps your EV roll along, right?
Yeah.
Well, the one thing that I've tested with my power cell, it also has a thermal conversion. So if I put my hand on top of the cell, the power actually starts to increase.
Freaking smart, Mike. You're smart. That's all I'm going to say about it. That's all I got to say about that.
Well, I can't really take all the credit. Michael Kantz was working on this stuff for like 30 years, right?
Oh, so you stand on the shoulders of.
Yeah, so we kind of taken over from where he left it, right? Because he passed away, but he didn't leave any literature on it. He kept everything proprietary. So anything that he wrote, in white papers or whatever, his notes, they were cryptic in the way he was talking, how he constructed everything, but he gave us a very good idea of what was going on inside the cell. So we're just kind of taking the reins from where he left off. We tried to decrypt everything that he told us in those white paper notes. So it's helped us go in that direction really, really quick and get the same effects that he was getting. So we're on the right track.
Nice.
So
Well, I want a battery, Mike.
Yeah. Oh, don't worry. When I'm able to release this stuff, I'll start making battery chargers and stuff
When
like that.
you're able to release some stuff, I'm gonna come out there and give you something I've been working on that I've built, and we'll do an exchange. Like I'll pay for it or whatever. But I got something for you too. But I'll have to give it to you in person.
Nice.
Yeah. And then we have to get Nathan out here up in Canada. Come up to Canuckville where we live in igloos.
How far up there are you? Because I'm here in Washington, not that far from Canada.
Sorry, I lost you guys there. Sorry, I lost you for a second. Went into a dead spot.
See, we should get a get-together going. You guys should all come up here. I mean, I'd love to come up there, but I can't travel, so that's why I keep trying to get everybody to come out here. We'll do a big get-together.
Big shindig.
Yeah. My family's got land. We could put together a big party, so to speak, right? What?
So, So, like, a lot of my research has been around trying to come up with a method of protecting the sacrificial cathode. So, I can't understand why battery companies kind of gone in that direction, or at least admit to it. There's a lot of guys out there doing this stuff. From my partner, he has a lot of connections in the US at MIT and a few other universities that are working on battery tech. And from what his buddy is telling us, due to our results, he says we're ahead of them. In some of the big universities, we're actually ahead of them. And we got we got no budget. We have a shoestring budget here. That's
probably why you're ahead of them.
Yeah.
You have to think outside the box.
Exactly.
Like even if I were to have, say, I'm just going to shoot a number, say $100,000 to play with. You know what I could actually do with that? A lot. I could literally. But these guys got millions, and they're getting nowhere. That's the kicker.
That's what makes me think, though. And I'm not discounting your genius, Mike. You could have stepped onto something that was just incredible that nobody's ever seen. But I think that they have this kind of tech and won't bring it out. Because again, like we said before, it's all about money, right? And who controls the money? Controls the market.
This would put Duracell out of business. It would put Energizer out of business. When I got a battery that could be the same size as what they have and run for 5 to 10 years. What? Really? Like,
they're going to want to sell that.
When they're putting out garbage and people are buying it in the tens of thousands or tens of millions, and they're making what's the Duracell? How much money do these guys make a year? It's probably off the chart.
Yeah,
hundreds of millions of dollars.
But have you taken into account Elon Musk built his own lithium-ion battery factory just for his cars? So if you think about that, and you're able to somehow contact him with your battery tech, man,
we already have. We already have.
Okay, well,
we already have.
Say no more.
I'll leave that alone.
Yeah,
we already have. The new big battery that's going to be pushed really soon is not lithium ion. They're going to sodium ion battery.
Mhm.
That's going to be the new lithium battery. So even Elon Musk, he's looking at these batteries now because the stuff coming out of China right now is kick-ass compared to what he has.
Nice.
So you're getting about three to 400 kilometer or 300 miles more on a charge with the sodium ion.
Couple that with a generator that charges batteries as it's running itself and drive anywhere.
Well, ultimately, that's what I want to do. I want to make a unit that I could put inside a regular EV that's on the road right now. And while your car's sitting at work and you're working, those batteries are recharging the cell that runs your car. And then you get out of work and your car's fully charged.
If you
Right?
want, we could talk off air. I might be able to help you with that.
Yeah. So that's my dream, is actually to make a car that recharges itself.
Mhm.
That would change. That'd be a game changer for the auto industry right there.
Yep. You can go after the cars. I'll go after the electric bikes and scooters. I don't want a big piece. Just look.
Nice.
But that's how disruptive this is, and that's the other
Yeah.
thing too. And
But you got to be
Yeah.
careful too, because it's disruptive enough for crazy things to happen, right?
exactly. So that's why
Yeah.
we're deploying it the way we're going to deploy it, very, very covertly, and hopefully that'll help us out.
Yeah, I hear you.
So, but the technology is real. It's just another method of making free energy.
Yep. There's a lot of talk about free energy out there right now, and I would have to say that's a lot
It's getting traction. Yeah, it is getting traction. I'm starting to see some headline stuff.
We pissed off some people because we gathered together and started discussing the things that they already know, but use their scientific terms to explain. And most of the public doesn't have a freaking clue. And it's not because the public's dumb. No, it's because the public doesn't have the
resources,
vocabulary to understand what they're saying.
Well, and also the resources, right? The resources to make this stuff, but that's changing now. The regular everyday guy inventor in his garage is making stuff that they're doing in multi-billion-dollar laboratories.
Yeah.
They're getting the same results of stuff that they won't release. That's scaring them.
Yeah,
that's scaring them.
Because once the genie's out of the bottle, you can't put him back in.
That's right.
That's right. It's out there.
Gonna blow the doors right off this place when we do it.
So eventually, so many people are going to be making these devices at home, where it's going to become totally undeniable that these devices have existed and have existed for a long time.
Oh,
now the average Joe Blow like myself comes along and does and replicates some of the stuff that are done in these giant laboratories and better results.
Well, see, here's a theory that I have about that. I think that they came up with a lot of this stuff prior. Like we said before, there's nothing new under the sun. I'm not discounting your discovery, Mike. I'm just saying I think that they have a lot of this stuff, but they don't want to release it until they can get themselves in a position where they're the hero of the story and they're the ones bringing it out. I've seen it amongst the academic fight recently. I don't know if you guys attention to everything that's going on, but
academia is a religion.
Oh, of course it is. Yeah. No, I get that totally. And they don't want anybody to step on their accomplishments in their religion, and unfortunately, that's what we're doing. At least in there. What's that?
See,
I didn't catch that. Mike said something. Go ahead, Nathan.
It was Jack Safari.
Well, Jack and David Rossi now, and Ashton Forbes was talking about it. Now Jeremy
Yeah.
Reese is bringing up free energy, which I'll tell you this. He's never, in the 3 years that he's had that channel, brought it up in a serious way whatsoever. When he brings it up, he makes fun of it. And he makes fun of the people that trying to accomplish it.
Who's
Which,
this? Jack Servati or
no, Jeremy Reese. But now he's
Jeremy
honestly
Reese.
taking it seriously. And he's brought up David Chester, who there was some drama on Ashton Forbes' channel the other day, but he brought up how David Chester has taken apart Thomas Bearden's work, and it's all debunked, except for there's a couple anomalies in there that, should be looked at. I can tell you this, with doing the Thane Hein reactor, like that transformer, and doing all those experiments, I think that Thomas Bearden was dead on, and they don't want nobody to know because he had an easy system to build, like easier than most people understand. So yeah, we've kind of stepped on some toes that are getting a little irritated. And I love it.
Jeremy was looking at geometry. Sorry, Jared was looking at geometry a lot on his channel for weeks and weeks, and then now he's talking about free energy. I mean, could be a coincidence, huh?
Maybe.
Go ahead, Mike. I'm sorry.
No, it's okay. Yeah, like I said, the stuff is coming out, and they don't like that, and that's the problem. The internet has been a huge source of information that inventors like myself and you guys were able to build stuff that is getting results.
Mm-hmm.
You don't have to be in a huge laboratory to do this stuff.
No, you just have to know what you're doing.
Yeah, or at least have the guts to play with things that are outside the box. Get zapped a little, blow some stuff up.
That's it.
Yeah, daily.
The quality stuff.
Yeah, I wonder. Do you guys remember when the government guys or whatever were saying, "Yeah, there's not going to be disclosure. It would take an act of God for them to reveal it." What if that act is one of us finally,
Coming around
and showing it? Then there'd be proof. They'd have to. So maybe they want it out, because I've been noticing lately we're going into an age of Aquarius, and if you study the yugas, there is always, before a golden age, a small ice age, sometimes lasting 100 years.
Yep.
We need that energy now, because if winter is coming, like Game of Thrones, they know we're going to suffer something before the golden age. So we have to wake up and remember to survive it.
Can I give you a little woo, Victor?
Anyway, yeah, go ahead.
Okay, so what if there was a system out there that was found but not talked about, that if this little ice age was to start, not only would you survive it, but your aging would pause for that 100 years of that ice age. And you'd have full power for anything you needed. Your food would grow 2 to 3 times as fast. And it's a whole system that works together with your environment. So it's big what if. There's some woo. Just saying. Like you said, what if God is the one that's bringing it around? And they want it out, but they can't bring it out because they've made a deal with the devil, sort of speak.
Actually,
aliens or whatever.
I think the powers to be still don't want it out, but they know it's coming out because they know they can't stop it.
Well, if they want the human race to continue and advance the human race whatsoever, this either has to come out, or, I mean, let's face it, we're headed down a dark road right now, and the road needs some light, and the light's gonna shine. And when it does, it's gonna be so bright. I hope everybody's ready for it.
You know what? The elite people who run the planet right now, they know they're on a timeline right now because they let a genie out of the bottle by accident, and they were never able to get full control over it. And that was when DARPA released the first versions of what we know of the internet today. And when that
They
got
did.
released, that was releasing the genie out of the bottle.
They
That was a
underestimated the intelligence of those that were listening and using the internet. They underestimated everybody, and that was a fatal mistake because there's a lot of very smart people out here.
and they cannot put the cork back on the bottle.
Nope, they can't.
So they know they're playing with the timeline. So they'll go to great lengths to keep that control. And
Very true.
Unfortunately, a lot of people are going to die over it. Actually, a lot of people have already died over it. Like you said, we're going down a dark road right now, but there is light at the end of that tunnel.
I believe there is 100%, or I wouldn't be here. Because I look at it like this: I died, and if what I was told is true, then okay, that's coming. Because otherwise, when I died, I would have stayed dead. You know what I mean? Not to say I'm anything special. No, I'm just like you and everybody else. But when I died and I was told there was something I had to do, and all these years have passed, and I come across this tech, and it wasn't by accident. It was through dreams and visions. I'm telling you, I believe that this tech is to come out, and I believe that it's to help as many people as humanly possible. And I don't think, like you said, I don't think they can stop it. They're going to try, but I don't think they can.
Well, they already sent Jack out to stop it. He did a heck of a job.
Yeah. Well, they're not done yet. They're still sending their minions.
He's flashing his credentials as he goes into every show.
Yeah, I'm calling everybody schmucks.
That's right. We're all schmucks.
Prior, I'll tell you guys a woo story, a quick little woo story. Just prior to me getting involved in this tech about 20 plus years ago, I had a dream one night, and I woke up during the dream, and I had this entity come into my room and basically threaten me. They said, "Do not go down this road, or it will be fatal." And it was, I don't know what it was. You could call it a ghost or whatever it was, or an entity of some kind, but it was definitely severely demonic. And it said, "Do not go down this road of energy."
Then that's the right road to go down.
And that's where the whole thing started right after that. So that was well over 20 years ago that happened. And I went down this road, and, like your story, Gerald, is similar to mine. It was a bunch of little things that led you down the road where you got and eventually got into this stuff. Same thing with me. Mine started at the age of 5. So I'll say that it started at the age of 5, and it was just one event after another that started enlightening me more and more and more. And when I got into my mid 20s, I had some pretty profound things happen to me, and I was still trying to figure it out, but I knew what direction I was eventually going down, and I just kept going. And I never looked back. So but I was definitely threatened.
I think that everything happens for a reason. There's a reason for everything. And when it comes down to threats or fear and somebody who's trying to promote fear into you to stop you from doing something, that's when you turn around, you put both feet to the ground, and you head at it with everything you got. You want to know why? Because fear is nothing but bullshit trying to get you off the right track. That's it.
Well, put it to you this way: I've been taken off the road in my car more than once.
Yeah.
Like intentionally taken off the road. Actually, one of them where I actually hopped the curb to avoid a head-on collision. And it happened. It happened. The perpetrator, same car, 2 times on the same road, 2 different days in the same month.
Wow.
Yeah, somebody didn't like you.
Yeah, like we're talking head-on collision. Like The guy was going excessive 80 mph.
Jeez.
Yeah, somebody didn't like you.
Yeah, I had to jump the curb. I had to drive right onto a friggin' lawn to avoid the crash.
At least you avoided it.
Yeah, twice.
I wanted to address this question really quick here.
Yeah.
Do you believe you have died? Yes. I put my fist through a window to punch my best friend at the time in the face. I got him in the nose. I also tore everything in my wrist except for my pinky tendon, and I lost a pint and a half of blood out of my body. And I was on my brother's floor and passed out, dead. My heart stopped. Ambulance attendants came in. There's a whole long story to it that I already talked about it, but I don't believe that I died. I know that I died. I went to the gates of what you would call heaven, and it wasn't a gate, it was a door. And there isn't a person alive, dead, on this planet or otherwise that convinced me of otherwise, because of the experience that I lived through and my life after that. It's changed. There's no denying in my mind and heart that God is real and Jesus Christ is real, because that's where I experienced everything. Anyway, I don't want to preach, so I'll stop.
Yeah.
Sorry. I just want to answer that question.
Yeah, I think one thing that kind of really affirmed a lot of stuff I was doing and what I was getting into and why I was being targeted is when I was able to do some experiments which created dimensional shift and also time shifting. I noticed at that point a lot of crazy stuff started happening to me, threats and the incident in the car, stuff like that when I was doing those experiments, and I was successful on time shifting and dimensional shifting, and I actually
That's when they don't like you.
And I also had entities enter the room during my experiments, like half in the wall, half out of the wall. Like crazy stuff, like stuff you would see in a movie, like really.
That's
really
interesting.
wild stuff. Some of
That'd
the
be cool.
when I had my end machine running, I had my pulse generator running, and what else did I have running? I had a couple of plasma balls going. I got entities coming into the room.
Yeah. Yeah, you know what? You may have been creating an electricity form or frequency at a certain level of voltage that was pulling that. I don't know what you call it. I'm not sure if I believe in ghosts the way others do. I call it a snapshot in time of emotional.
Yeah, I think it was a dimensional shift. I don't know. The entity I saw, it came out of the wall right beside the toilet, and it was watching me. And then it went back into the wall again, and then came out again. It was, I'm talking crazy stuff, like like sci-fi crazy.
That's cool. I wish I could see that.
Oh, dude, yeah.
I shouldn't wish for that.
Love to see that. Some dude coming out of the wall. Oh my god, dude. I'd be like having a conversation, offering him a beer. You know what I mean?
Well, you ever heard of the shadow people?
Oh yeah.
Well, that's kind of what it was. It was like a shadow figure coming out of the wall.
I've only dealt with that once. Just once. And I kicked it out of my house so fast.
And it was every time that happened, I was using the end machine.
Remember, you have authority over those things. They don't belong here.
Yeah.
So if they get in your face, chuck them out.
That's it. I got to fire up a ton of electricity in my garage tomorrow. No getting around it. I got to have a beer with the invisible guy coming through the wall.
Not even that.
I got an energy goal.
It's a rotating magnetic field, and the end machine creates that. And Bruce De Palma, when he was doing experiments with the end machine, if you put a clock on its axis, like on the shaft of where it is, it actually starts slowing time down. and he actually proved it with an analog clock. So,
Another way of I found this out by accident. You get issues with a rotating magnetic field from an alternator if you're running your alternator in your house. Because I've built an alternator generator where there's a treadmill motor that spins 3 separate alternators, and when I got
I've seen that.
yeah, when I got it going fast, there's some weird stuff that starts to occur in the basement. So you're not wrong. Rotating magnetic fields, they do weird things.
Yeah, like the magnets I was using on my end machine are those fishing magnets. They got a lifting capacity of like 600 pounds each.
Yep.
So I had those spinning at about 5,000 RPM, and I was hitting it with high voltage. So when I was hitting it with high voltage, it's spinning at 5,000 RPMs with a rotating magnetic field. Things start to happen.
I see why you have problems.
Yes.
Yeah.
I wish I had a Tesla coil hooked up to that thing. I wonder what would have happened.
Well, it's the same as your high voltage input. That's what a Tesla coil is, in a sense. I mean, you're not trying. So, go ahead.
I only had 220 volts AC hitting it while I was running it, and I was getting those effects. Now, if I had a Tesla coil hitting several thousand volts.
Yeah, I get that.
And the other part was because I did it in a basement of a house, that was able to kind of hold that field there because of the cement walls around the basement.
Yeah.
So I think that might have had part to do. I was able to isolate that rotating magnetic field in that space, and I saturated the entire room with that rotation. And that's when all the funny stuff started happening.
Yeah, I can kind of see why. You created a whole environment, like the perfect environment.
Yeah.
And no, nobody should fear shadow people. Go ahead. Sorry.
No, it's still like you're creating the perfect storm, right?
Yep. Yeah, well, that's what I mean by environment. When you're creating a rotating magnetic field with high voltage that's involved in that, and it's going at a certain RPM, your RPM is defining your frequency, right? So if you're sitting in a place that has a history, there could have been some sort of emotional damage with somebody who lived there in a previous life. And that plasmatic frequency attaches to that in that time frame, lights it up, and you see it as a ghost.
Yeah, it could have been. I'm not ruling it out, that's for sure.
Yeah, I mean, hey, I'm no pro. I'm just thinking about how that might work, right?
Well, you said you had similar things happen, right?
I've had some crazy stuff happen. Like I told the story about at my girlfriend's there, and her best friend's stepdad who killed himself upstairs. It was a ball of blue light, which now I know to be an Evo that went up the stairs that we followed, and her brother was getting like almost pulled out the window, but he wasn't pulled out the window, but the angle that he was at looked like he was being pulled out the window. And if we hadn't got there in that time, he would have literally gone out the window. So I don't know what to think on that one, but like I said, I believe it's an emotional stamp in time. Can that stamp interact with us when it's been recharged and playing through? I don't know. That's a very interesting question I've never considered. That's why when you hear about, like what you said, Mike, about interacting with this, and it's almost like it's conscious, I'm not sure. I'm not saying you're lying. I don't know how to think about that scientifically. You know what I mean?
I think it is conscious.
It could be. I don't know. Like I said, it's just a theory, right?
I know a guy at the park that's conscious, and he shows up every time I go walking at the park. I go once a day for an hour, right?
Yeah.
And this dude shows up in this white Tacoma, okay? And then there's always another guy that shows up at a park bench on the other side of the park. And then when I leave, if I come back, they're leaving. But if they're not there, right, when I get there, they show up. So I don't know what's going on there. It just seems strange. So I start writing down license plates and descriptions. You know what I mean? Because
Good idea.
yeah, something's going wrong there.
Yeah.
And I don't like it. So I might have to change parks and see if they show up.
Patterns matter. When you're being watched, if you're being watched, they matter. I was I had the fortunate point in my life where I had an uncle who is heavy into military, and he was very intelligent, and he did things for certain governments. Anyway, I was taught some things on how to watch if you're being watched, and it's all patterns. Watch for patterns. Cars that follow you at patterns 3, 6, 9, and 12. They switch patterns sometimes. You just watch, you'll see it. And if you see that same car all the time at that same spot, it starts to form a pattern. And that pattern, I'm telling you right now, there's no such thing as coincidence. You know what I mean? So yeah, those guys showing up, that's a hell of a coincidence, Nathan.
Yep. They started showing up when I started doing a lot of my Gravity Flyer videos.
Yeah, not surprised.
It was probably, a month in, and they started showing up, and they haven't gone away. So I just stay away from them. I don't want to get, pricked by anything as I walk by. So I kind of weave the other side, stay away.
I hear you.
And if I see them out there doing something stupid, or some guy's got his dog off the hook, man, I'm out. I just leave. I don't want to get any kind of interaction with people while I'm there.
Yeah, because that's how they make friends, and you know what I mean? Yeah. Synchronicity, I believe in synchronicity 100%, but synchronicity comes with a flow, and it's a flow that's beneficial not just to you, but to those that are around you that are in the flow. If Nathan's being watched, or if he's not, and he's seeing these people, if it was synchronicity, he would accidentally get involved with them. They'd be good people. Maybe they're working on a gravity flyer. It would flow as if it was meant to be. If it's not meant to be, and you get a feeling that something's not up, like something's not right, something's up, and there's too much coincidence going on, 9 times out of 10, that's the truth. And there's something going on you're not aware of. So,
yeah, I don't talk to people outside of what we do here. You know what I mean? In my personal life, no, thank you. None of them even understand it. And then any people that come up to me, they don't talk to me about that. So if they did, that would be really strange.
yeah. But if they befriend you and then it comes up in a conversation, it'd still be strange, but it would be relatively normal for most people. You know what I mean?
I guess. I don't. Besides
no,
you guys, man, I don't call anybody back. I'm sorry. I'm that guy. I'm a hermit. You know what I mean? I stay within my system. I don't. No, thank you. I don't have the money to go to places and concerts and all this anymore. You know what I mean? I'm old and retired. You know what I mean? I don't have enough beer to share. So, sorry, pal. Bring your own beer.
That's the right way to put it. I don't have enough beer to share. BRB, man. Bring your own beer.
That's right.
That's awesome. Oh, so playing with some circuits.
We'll share some with that guy that come through the wall, though.
Yeah, that's a little different, right? I get that.
I'll share a keg with that guy.
Yeah.
The stuff you could learn, right?
Oh, it's so good. All right, Gerald, circuits. What you got circuits at this late hour?
I got nothing to show, just something to tell. I will show next Wednesday. I'll bow my head and shit. So now that that's done, I've been playing at some circuits, and I got the Doppler effect happening at the flip of the switch now every time.
Nice.
Yeah. So now it's a matter of putting in enough energy. That's it. So we're almost there. We're that close.
Hey, Gerald, can I give you a little tip?
Yep.
Stop doing experiments and listening to us because we're never going to get your presentation. Just turn us off. You know what I mean?
Okay.
But stop playing with things.
You said turn you off. I mean, I don't know.
Oh,
You're
come
not
on.
wrong. You're not wrong. But you know what? The work's got to continue. You're right though. I really got to get my presentation out there. Like I said, I just got to get that link from you. And
I sent it.
you did?
I did. I don't think you check your email a lot. I have a distinct feeling.
You know what? I do check it, but I'll tell you, there's emails that are missing, and sometimes I get your emails 2 days later. Go figure, right? I have that problem with Jeremiah. He would go ahead.
They got to go through the government filter before they get to you. So I may have to type out one letter on each email until it gets there.
700 emails later. Love it.
Oh,
I don't know why I didn't get that one because we talked about it the last stream and then.
yeah, I sent you a code with it. There's a code on it for you.
Okay, I'll look at it. I've got your.
By the way, on StreamYard, Gerald, when you go in there,
yeah,
you can open a screen like this. Up in the right-hand corner where it says comments will be a record thing. You can record what you're doing on StreamYard on a private recording. Then StreamYard has an editing tool in it as well so that you can edit videos in StreamYard.
Oh, really?
Yeah, so you have everything right there. Just use your webcam to do your video, and you can do it right there.
Okay, but that's for live podcasts, right? That's
no, it's private. You could do it private.
No, I get that, but I have clips and things that I've been putting together.
So you present them on the screen and talk about them just like you're doing right here.
Oh, I get what you're saying.
And record it all as one, and then go back into the editing tool and cut out the gaps where you have like a dead spot or you're moving things around or whatever you're doing. It makes it really easy, and it's already in the software that you're using that you have.
I'll check that out. I will check that out and see if it works.
By the way, Bernie said there's hotkeys on this. So every time you hit B, it'll mark it on the thing where you can go back and look at that spot.
Really?
Yeah. Bernie's been pulling it on us. No, not in a negative way. He knows where to look.
I was going to say, see that Bernie's always pulling something.
Now Bernie's smarter than us. We just don't know it yet.
I know.
He's over there singing the pineapple song and figuring out what we're doing.
One thing I'd like to do, Nathan, at some point, I'd like to do a presentation on the Renegade device and how it works.
Oh, dude, I'd love that. I'd absolutely love that. Like a whole show on it would be cool.
Absolutely.
Because there's a lot of people asking me questions, and it's like, refer to my videos. It tells you everything there. So I like to put a presentation together and show it to everybody, and then there's no misconceptions. It's there. You can see it.
Right? Absolutely.
Sounds good.
Yeah, have us on, and we'll all ask questions about it at the end when you're done presenting. So it gives everybody a better thing, and then pull the comments, and we'll do those too.
Great. Because a lot of people, I think, are not aware of a current free potential system, and I have a way of explaining it that will make it a lot easier for people to understand.
That'd be totally awesome. I personally would have loved that from day one when I first saw the device. You know what I mean?
Yeah. It's hard to wrap your head around it, but I'll try to explain it in easy terminology that the average Joe like myself can understand.
Yeah.
So.
Yeah, do both. Like in my presentation, you're gonna hear the scientific term, and then you're gonna hear me explain how I do in layman's terms, like garage mechanic terms, so to speak. Nice. Right? Yeah. That way everybody can kind of get that the academic vocabulary is no different than what we're working on. It's just a different way of saying it.
That's what I want to do. I want to take away the academia type terminology. I want to put it in regular plain English that any Joe Blow can understand.
That's right.
Absolutely. Yeah.
Right?
With lots of metaphors that they can understand. Right.
I wish there were a lot more people out there experimenting with the spark gap switch, what I totally 100% believe is one of the keys to this. So I want to make guys out there that are making Adams motors using Mosfets and stuff like that, or SSRs or whatever, to get away from that, go with the spark gap switch. You're going to see a phenomena that you haven't seen before. So I want to explain that.
Awesome.
That'd be cool.
Spark gap is important in many different ways.
Well, I believe it's the orifice and where that extra energy is coming into the system. And a lot of stuff, there was a couple of the lectures that Dollar did where he was basically saying the same thing.
Yeah, well, a lot of people seem to think that, right? And it makes sense if you look at it from an implosion point of view. As that spark gap explodes, it also has to implode just as fast. And as it collapses, it's pulling everything in, right?
Right. So all the ether energy that's surrounding that spark gap is now getting drawn into the system. The spark itself is the orifice for that energy to enter.
Yes.
So,
whereas my coil, because the wire is so close together and under so much tension, that's actually how the energy enters in. Because in between each line, as that plasma is formed and it's imploding and exploding so fast, it's pulling it in and out, and it's like breathing, right?
It's breathing, yeah. And if you want to get into the real kind of woo stuff, I've done some experiments with my device that makes me believe that if you get it at a certain frequency and a certain amount of voltage going into the system, how could I say this without getting too woo? It's like the motor becomes an entity. It takes on a consciousness of its own.
Like a living system?
Yeah, like a living being, yes.
Interesting.
That's cool.
Yeah.
That's about as woo as I can get.
I can get more woo, but I'm not going to go woo.
But when it hit me, when I did a couple of the experiments that led me to it, I couldn't touch the motor for the next 3 days. I was in total friggin' awe. I could not believe what happened. I could not believe it.
That's crazy. I can't wait to come visit you and you can play with the
That there was a life-changing moment.
No doubt. No doubt.
Yeah.
Now I want to have a beer with the guy on the wall.
That's right. I think he knows a lot more than what he's telling.
See?
Somebody take some shrooms.
Yeah, it was like an acid trip, if you want to call it that.
Oh, that's so funny, yeah. Yeah, Gerard Moore was talking about the spark gap system as well, and he didn't say always directly that it was pulling it in, but he would always point to the fact that he spark gapped it 3 times and the energy would amplify.
Yeah, wouldn't it actually turn into a purified sine wave after that as well? Because he went through 3 separate spark gaps. I'm not positive on that one though. I don't know if you guys heard anything.
My motor basically, I would say, reacted to some stimulus that I gave it in a way that I didn't think was possible. And that just put me over the edge. I was just like, whoa, I got to step away from this. because I was getting spooked.
I hear you. I got spooked when my coil hopped. So I totally understand. I really do.
Yeah, it really spooked me big time. I
Yeah.
was like, what the? I just
Oh,
like, whoa.
You're dealing with forces that are outside of the norm in the sense where you're like coils and spinning magnets. You'd think, okay, well, what's that big deal, right? But it's still out of the realm of most people's understanding. You're dealing with a spinning magnetic field that attracts electrostatics. It literally tunes the environment to that spin. So you're changing things that normally wouldn't be changed. So I'm not surprised you're seeing out of the realm stuff, so to speak.
Yeah. Creating a waterfall in the ether.
Yeah. Spinning magnetic fields are awesome, unique, and need to be studied.
That's what got me into all this. They're so fun and they're so interesting to learn about.
Yeah.
That's right.
Absolutely. I wish I had more to share, but it's kind of been such a long day. I wasn't prepped for today. So, and this audience has got to be getting sick of hearing that. So. I'm Canadian, okay? I apologize a lot. I'm sorry. Yeah.
Oh, yeah.
Yeah, it's all good, though. I have that video I got to release, too, that I said I was going to release last week. I did put 2 on Rumble. I don't know if the other one, I couldn't find it after I put it up, though. I don't know if something went wrong. I may have to upline it. And I got your email, Nathan, about the frequency and the winding. And
Something telling me I was wrong about that. There's something more there.
Yeah, there's something more there.
Okay.
Yeah. You're close, though. You're along the right path of thinking, but a little different. Like I said, once you get it, you'll be like, you're a dick. Sorry. You'd be like, you should have just, I could be doing this all along. You're such a, sorry, Nathan, I can call myself out too, right? Yeah.
Gerald, you're hilarious.
Yeah.
He's a funny guy. I love Gerald.
Sorry, guys. Just, I want to just like release it and tell everybody, but I got to be smart about this. And there's a reason.
Nope. I completely understand, man. Do it at your own pace. I want you to get your theory out there and all this stuff because I'm making a video right now that has to do with coils and stuff, and I'm putting all the information I have into it, right?
Uh-oh.
But it may step on your feet, so I have to wait for you to be done.
Okay. So I'll here's what I'll do then. Because everybody's been waiting so long, and I'm getting, shit storms of people going, when is it coming? I'll give a day. How about that? And I'll dedicate to a day, and then I'll have it done. So let's say this. Next Wednesday, I'll do my presentation.
Do you want to do it on Wednesday? Usually you're busy during the week. Is it?
Yeah.
You gonna have time?
Think I should do it on a Friday?
Friday, Saturday, Sunday, you pick. You can do it on Monday. We have Mike coming up with his machine. His Renegade. And
so when's Mike doing his then? Mike, did you decide? Or do you know?
What's that?
When are you going to do your presentation?
Hopefully in the next week. I figure in the next week I can do it.
Okay.
I have to get some, I guess, like slides or something like that too.
So how about this then? How about I dedicate to next Friday? I'll do my presentation.
You have time because it's going to take hours to do, so.
Yeah, you think it,
Well, you could probably give an hour presentation. You get probably half hour to an hour of questions. You know what's coming.
Yeah, you're not wrong. I can't say I'd be ready for this Saturday, but I can say the following Saturday I'd be ready for sure. So you want to we'll pick that day then. Not this Saturday coming up, which is what? The 12th, but the 19th. I'll give my presentation on the 19th. How about that?
Okay.
So now,
you 100%. No, nothing.
Unless something goes wrong with the editing, but I'll be in contact with you. So in a worst case scenario, I'll get that code off you and I'll use that editing program. That's the only thing stopping me right now. I could do the presentation without the videos, but then, you know, the visuals, they help. So that's my goal. So 10 days from now, whether the editing's done or not, I'll do the presentation.
Well, you can also do it here like Shawn does and just bring up the folder and go through each one.
Oh, yeah, I could do it that way too, couldn't I? Instead of editing it. Ooh, I'd have to open a few windows though. Yeah, you know what? I'll practice on that and see if I can do it that way. And then, you know, yeah. I like that idea. I'll practice and see if I could do it that way. That way I don't have to go through the editing. And then I can guarantee that on the 19th it'll be done.
All right. Well, we're
I'm
getting to that, Gerald. If it's not done by the 19th, man, everybody in that chat.
Okay, so if it's not done by the 19th, then everybody can hear this. Nathan can do his presentation. And if he steps on my toes, it's on me. Is that fair?
Yeah, but it's going to step on your toes a lot. So you have to do yours.
I'll do it. Don't worry.
Normally,
I'm going to come.
If you're nervous about the presentation, to just imagine your audience naked, but that didn't work for me. I'm just telling you right now.
Don't do that.
You don't want to do that because some people in the audience, I'm going to be walking around with things like, you know, you don't want to do that. Right? It's bad. It's bad.
Oh, my God.
That's not what I'm nervous about.
With this audience?
It's whether or not I've messed up on my theory, right?
Well, even if it's off and you have to course correct later, you know, it's understandable. I've had to do that many times where I've had to correct myself and be like, oh, I was wrong on this. Sorry, guys.
Yeah. And
people understand.
Yeah, I've done that before. I've been wrong before. I think
it just shows us you're not a robot. That's all.
Yeah.
Every time I do a live show, remember, there's a lot between here now and then. I'm going to promote it. So I'm going to make sure, okay, everybody gives you the biggest grief in the world if we don't get it. I'm going to talk to Ian. He's going to tell you a couple Irish terms there.
Oh, Ian.
Me best friend in there. Yes, I do understand. Yes. Have a sip of whiskey. Sorry. He's going to kill me, I'm telling you. Just kidding. I shouldn't say those words. I'm going to get myself in trouble. It's this mouth of mine.
Yeah, because I'm putting together, by the way, just so you know, I'm putting together the fractals, the geometry, all of it, the equations, you know what I mean, how each flow goes. And it would directly step on what you're doing.
You might actually be able to help me with some of the equations because, like I said, I'm okay with my math. I'm not great on it. This wasn't created through math. Math was an afterthought in the sense where how I did my work, right? So I should run that by you sometime in the next 10 days. We should sit down and hash that out. I don't know, though. It's pretty high end, like in the sense where, yeah, we should sit down and talk.
A little bit of Pythagorean theorem in there.
Oh, yeah. Yeah.
Get some geometry going on, something that they don't actually use.
A lot of
You got to do it over breakfast. It's always better if you do it over breakfast.
Yeah, there you go.
Break bread.
Yeah. Bacon and eggs, man. Sausage and grits. Just kidding.
Oh, I love biscuits and gravy. Oh my god, I'm from the south, so I eat that up. And grits.
Grits.
Good thing he's not English, because you'd be eating a spotted, you know what.
Yeah. And I don't do these things to be insulting. I hope you guys all understand that. I love getting a laugh out of people. When I'm in crowds and I do stuff like that, you get some pretty wicked laughing going on, right? And you get some upset people, depending where you are. But yeah. Why fear it, right? You only live once.
That's right. Hey, did you hear that, Victor? He's actually going to do his presentation.
Yeah. Not today. The 19th. I gave a date.
I pulled a prayer out my pocket for that one.
Yeah. So on the 19th, it'll be done. One way or the other.
That's right.
Yeah,
Nathan
I'm working
said
on them too. So
There you go. Perfect. I just hope I have it all together. We'll see. I think I got my theory down for this one. I've been working on it for a while, I'll tell you. But it's difficult because I looked at like Einstein's theory of relativity. I looked at Steinmetz's work, Tesla's work, Bedini's engineering, and to put it all into a theory is difficult because I looked for something to fit what my system was doing, and there isn't one theory. There's a whole bunch of, it's like a conglomeration of a few different theories.
well, there's a ton of them coming out in the past couple of weeks. I mean,
Yeah.
it's just been like a slew of different formulations around the same concept.
Yeah, funny how that works, right?
Well,
Yeah, that seems to be a phenomenon that happens. You know, people independently coming up with the same idea. It's almost like the universe wills it to happen one way or another. You know,
100th monkey experiment.
well, I got money that says after Gerald gives his presentation, they're going to be on fire giving theirs.
I have that feeling too. I have a feeling that there'll be a few physicists putting some things out, and a few mathematicians. Let's just say I think a few science groups might actually try and put something out too. So we'll see.
Well,
right?
If you do
yeah,
the
Neil
math
deGrasse
right,
Tyson might put something out saying, "Oh, well, this is why," and he's a stupid idiot. No,
so,
I don't care what you think of me. I don't care what anyone thinks.
yeah. Hey, your
Go ahead,
system
Nathan.
works,
Sorry.
and you have to work backwards from there, right? You know it works. You have to figure out why it's working. You're given the best explanation you can, and that's all you
why
can do.
I contacted Jeremiah.
Yeah,
I
that's
wanted
all
to
you can
find
do.
out, right?
And yeah, he's good with that. I like Jeremiah because he's helped me out understand some of these things too. But but that's why we're here. We're here to help each other.
But Nathan taught me more in a month than Jeremiah did in 3 years. Just because Nathan and I have that different language.
Yeah, you two have like that connection where you can
mechanic.
communicate
Exactly.
really well together. You know,
I had to learn the language to talk to Jeremiah. No offense, Jeremiah. I'm just saying.
well, I mean,
You probably laughed at that.
it is hard sometimes to communicate, like for me at least, coming from a layman's perspective. And Jeremiah, he's in the academics realm. He's very informed on some of these.
Conversation with a lot of different academics, but Jeremiah is more intense in that sense. So, yeah, I had to kind of learn the language.
But yeah, no, communication is important. And some people like, it takes time to learn how to communicate with each other, you know?
you have to slow down his words in your head.
Yeah.
You
Hey,
gotta
sometimes
pick out-
I have to do that with
No,
people. I'll slow down the YouTube
because-
video.
He used redundancy words, okay, in every time he talks. And if you don't know which one's the redundant word, you'll get lost and
Get
try to figure it
confused,
out.
yeah.
There's a way to do it.
Yeah.
You know what I mean?
Or
You'll just
You
trust
can
me.
go
When I
back to
edited
your
that video, when I edited that last food video, trust me, I
Yeah.
found every single one of them and figured it all out. You know what I mean? And in language format is exactly what's going on there. Okay, so it sounds more scientific in a certain way. You just have to know how to break it down. Like, man, if I just sat here and take all my words like a garage mechanic and to use a thesaurus, I could literally tell you words like this long, and you're like, wow, Man,
Yeah.
how did you know that? I sound like the smartest guy in the room, but like an English professor. I put on a suit and tie. You know what I mean? And
Yeah.
to sit up here and I might even shave my beard, and then boom, it's all over.
Yeah,
Finger
put on
foods.
America flag on your lapel and call yourself the benefactor. I'm
I
kidding.
I can't do it without that lab coat, though.
Yeah.
Yeah. Hey, the
And I
suit,
need a little hard hat right next to me.
I think a suit, like a suit and a tie underneath a lab coat, I think that looks sharp.
You know
Yeah.
how long it's been since I worn a tie?
I know they're annoying. I don't like to wear them a lot, but you know, when the moment's right, I think it'll look sharp.
Only once I've worn a tie. Wore a lot of silk shirts and silk pants.
I personally prefer the bow tie because you know bow ties are cool.
I used to have to wear a tie every day to work, okay, and show up in like a suit.
Yeah,
and,
same.
and handle work. So
Nice.
yeah, and
It
you
gets
manage
exhausting.
stuff.
I don't like wearing it every day. I'll put it
It
on every
chokes
once in a
you.
while. Yeah.
Yeah, it does.
Yeah, it's not comfortable, but I do like wearing a vest. Vests are classy, and I like it because I can put like a pocket watch in
I can go with that.
I like wearing clothes. That's about it.
there. I don't like being naked, guys.
I like wearing clothes.
That's so funny. It reminds me of that lion. The one when we did that Church Porter thing, and then I made you the lion, and I had to put a little sensor thing over the package of it.
Yeah, I remember now.
It's absolutely the best. Because I was gonna show it, but it just looked so wrong. So I had to.
Yeah, I was eating a sub when he showed me that circuit video he made, and it just spit. I was laughing
Nice.
so hard.
That video was the absolute best, Gerald, making a circuit.
That's
Because
that's
out of nowhere, you get this, thing covering your screen like you shouldn't look at it. And you're like, what did he do? And then Gerald starts laughing about it.
He's like, oh, I probably shouldn't have.
That's awesome.
Oh my God, that was absolutely the best. Because you knew it was coming, okay? Because you had 2D batteries up there, right?
Yeah.
And I kept drawing the lines wrong. Like when you would say this goes here and this goes here, I didn't put them there at all. I
know. I was laughing at that. I thought that was hilarious. If you seen the last circuit I drew, you'd just be shaking your head. Because I drew it and I went, this circuit's perfect. And then I stood back and went,
oh man,
it must be a Freudian thing.
Yeah.
I don't know.
Hey, I'm sure
tried
to some extent we all do something like that.
Right?
I tried so hard, Gerald, to put the extra line in there that you had, right? The one right in the middle, like it was going like this.
Yeah.
Okay? And every time I drew it, it was absolutely something I could not show on YouTube.
You see what I mean? It's horrible, but it's I don't know.
There was no way to show that.
Yeah.
Oh, it was the best.
We're on the fringe, not just of science, but of comedy now.
Life is short. Live it. Smile a lot. Laugh as much as you can.
Maybe we missed our calling. We should have been comedians or something and just made funny videos.
Yeah.
We could have. When you understand the science, I guess you can make fun of it. I mean, I don't know. Right?
Oh my God, dude. Oh, I make fun of things all day when I'm in there all alone and nobody's listening. It gets really bad. And then it's like, if somebody walks in, it's like, gotta go.
Yeah. We have a standing joke in my house. You were talking about how you made Ben laugh and he spit his sandwich out. Well, the little competition we have in my house is when somebody's drinking, we try and crack the funniest joke to make them spit it out. So, yeah, it's kind of a fun thing to do that we do around here. And there's 8 people in my house, so it gets interesting.
The game it must get intense.
Yeah, it does. A lot of laughs, though. A lot of laughs. Yeah.
Oh.
Yeah, but carbonated stuff coming out your nose is not fun.
No.
It hurts. You're not wrong. You're not wrong. It burns a little.
Oh my god.
Yeah, I didn't. I guess we didn't talk much about science since I've got here. I apologize, guys.
Oh, Gerald, did you read? You've read John Mackin's paper, right?
Most of it. Yeah.
Ooh,
And-
when you get towards the end, pay attention to the portion that talks about the ratio of a particle 43,200 times the distance. That's I think a key to what
42?
we, huh?
You said 40.
432,000,
Yeah.
43,200.
Okay.
I just remembered that number is supposed to be the scale of the Earth to the Great Pyramid. That it's a scale model, 43,200. The math apparently, and then since it's in his article, I was like, whoa, there's something there. And so we should get together and kind of discuss that point after you've read it. Yeah, I got some.
Yeah. Yeah, I agree with that. Yeah, I'm on board to discuss that with you for sure once I'm done. I had to put it on pause for a couple minutes because stuff going on around here, but
Yeah, me too.
yeah, I'll finish it and I'll get back to you on that because it's making me think. It's making me think. I have to read it because I don't know if my thought process is in the right position yet, but you got me thinking, Victor.
I want to see your presentation first, but
Yeah, well, there's not a lot of math in it. I won't lie to you. Okay, but I'm an intuitional builder, and that's kind of how things played out. But I've been searching really hard to find the theory to match to this. So I believe I've got it down. I hope so. We'll see. We'll see how close it is to Nathan's and see if he thinks I'm right or wrong or not. And I don't know. You can run it. Like, of course, I want your opinion, right? And I'll take it from there. Just remember, I'm no physicist. I guess you can say I'm a scientist. Because anybody can be a. What's that?
I said we're all scientists here.
Yeah, that's what I thought. So I guess you could say I'm a scientist, but I'm no theorist. So hopefully I've got it right. We'll see. I know how it works. I could explain it blindfolded in my sleep, but explaining it so that you understand in theory from not watching it work or experiencing that which I've experienced a little different, putting it into words, right? So
okay, I'm gonna show you something, okay? So I won't play the video, but I want you just to see some of the parts in it. Okay? Because of what it talks about. The shapes, okay? The actual sound that comes out of them. So you'll see a lot of them here. And this right here. You guys all
Sorry
take
about
out?
that.
Or?
No, my daughter was sorry
Oh.
about that. I was listening though. Okay, so go ahead. These frequencies you're saying?
432, right? Hertz?
Yeah.
Okay, it's a mathematical thing within your patterns of what chord you're in, or whether in your D, E, whatever, right? F.
Yeah.
But it also goes with the shape.
Mm-hmm.
The shape itself makes the chord that you're in.
Yep.
And it all has to do with 432. So, hold on. So, it also talks about the great year, and I'll send you guys this. I'm kind of skipping through it because I don't know if I can play it or not.
I think I know what video you're talking about. I might have seen that one.
It's really good. But it also talks about the pyramid and the same number that Victor just referenced. The 4,400, whatever. You know what I mean?
Yeah, 432,000 times the distance.
So just so you guys know, I'll put it out there for you guys, but it's absolutely amazing. I'll go ahead and throw it here in the private chat for you.
Awesome.
That's awesome. So sound, like you said, the tones, they produce their own shape. Well, what if you were using those tones to move those shapes?
In a field?
Yeah. Yeah. Say using the shape of those tones to create spin.
How about
Well, of course you are.
the shapes of the tones are the crystalline structure of the stones? It just dawned on me.
A little more to it than that, but you're dead on, Victor. You're dead on. It's also, go ahead.
Every frequency you make. So you look at the mandalas, you notice there's curved lines, there's also flat lines, there's circles, okay? They're all creating a different type of a field, whether that's in the rotation, whether that's the magnetic field, whether that's the actual sound, okay? All of it's tied together. It also has transmutation when you start creating the pump in the center of this thing, and then you have the top and the bottom going all together. That's where that whole thing fits in, right dead there in the center. It's like Joe said, you have nothing in the diaphragm until you tap it and create the frequency.
Yeah, I can see how he sees it that way.
And aren't all those numbers for those tones, aren't they all divisible by a power of 2?
There is that in there, yes. Well, square root of 2.
All of them, though?
Well,
Could be if they're harmonics.
Yep.
Yeah.
That's what I'm saying. There's a whole lot more to your coil. It's all of it in one. So it's all of it. It's not just a little bit. It's all of it. That's why it's so special.
You want to know what I was told? It's the heart of the pyramid. That's what I was told. The very heart. So 1/3 down from the apex on the inside of a pyramid, that would be where your heart of the pyramid would be, because that's where your highest energy level is before it continues forward in its movement. That's what I was told by him. I don't know how true that is, but
I was talking to Shawn about this. We were talking about the pyramid, and I was asking him about the shells in the walls. Okay, how they discovered that there were seashells in there. And the question is, was the pyramid underwater? Was it poured concrete? Let me just say it this way. I think they grew in there. And it has to do with the granite sucking up water into it like a sponge, okay? And it stays in there. And then when you get the piezoelectricity that goes off every time the pump on the bottom goes down, you use water hammer, okay? You get that field and it grows a little bit. And it grows more, and then more. And the piezo, and you start to get a pump, right? And it's pumping it up and down, okay? But what does that create? It creates and mimics the earth. So in that wall that's covered in all that water, okay, it doesn't matter if the thing's underwater. It's soaked in water at all times. It's going to create that thing. It's going to create those shells right in it. So when we were talking about his coil and how it works, I was telling him when you start creating the fractals on the outside of the sphere, if you cover it with another one, you're going to start seeing fractals everywhere. Why? Because you're going to see the same thing in the Great Pyramid when you start doing that. There, instead of fractals, instead of seeing the fractal, you're going to build shells piece by piece by piece by piece, and they'll build them. It's the building blocks of life. It's just all right there.
Let's okay, so building blocks of life, maybe something to connect it or has to do with the flower life itself. That's actually I shouldn't get too much into that to my presentation, actually. But it's part of it, in a sense.
It's part of what John says in his paper too. Even though he was showing the particles going in a plane like the yin yang, he says they're actually higher dimensional spherical shells, and the shells, and so atomic shells are not particles, they're vortices.
Yes.
That's right.
And what we think is a particle is the center gravity line that's holding the vortex.
Yeah, I agree.
Nathan, do you think those shells could be some kind of like self-repair mechanism?
Self-sustaining oscillations.
Yes. Which would act as a repair mechanism in a sense.
One way, the next going, like you said before.
That's what I was thinking. Okay.
Yeah, so when you see, I think it's calcium deposits in the ocean, and then they create the shells based on that. When they get, you know what I mean, the field of the earth pumping it in the water, you're going to get the energy all around it. That's basically what the pyramid's doing. It's creating energy all around it because of the water hammer underneath. But the cool thing is once you start the water hammer, because the actual piezo electricity will work like a Tesla coil, it'll create the pump. The pump will actually make that water hammer hit harder. So then the amount would get to a maximum level at that point, because it'll start real small, but then it'll grow to an enormous level. So all of Egypt would be green, not sand.
Absolutely. And because of the way that the pyramids work through ionization and all that, your ground from that energy in the pyramid would literally, the Nile is what acted as a ground. So that ground line, providing that the pyramid was pumping out enough energy into the whole environment in that area, because the River Nile was the ground, anytime you planted something, it's like growing between two capacitor plates. It grows twice as fast and more luscious and gives you more fruit. Why? Because it has all the energy to do so. So,
okay.
Go ahead.
Just so you know, your whole coil is in that pyramid. You can draw a line right to it. It's the same thing. They did it out of stone.
Yeah.
I mean, so much work you put into this coil, right? And they're doing it out of stone back then. You know what I mean? It's got to blow your mind at some point.
It was genius because it lasted through the ages long enough to teach this generation.
Yeah.
Or at least we're going to attempt to anyway.
Well, once it's out there, here's the thing. All it takes is a spark. So once we get it out there, right, and we put our theories together, even if we only have 90% of it by the time it's over, that last 10% is going to come in with mathematical people, you know what I mean? Testing that's going to come in to do it. All these factors are going to fall like dominoes right afterward. So every theory you're going to have out there is going to be about sacred geometry. It's going to be about coils. They're going to say they discovered exactly how the pyramid works. All of it's going to come out, right?
Yeah.
And then we're all going to be sitting here laughing because we did this show and we already knew it.
Absolutely. Absolutely. And we're going to have to do a Rumble show as a follow-up to talk about what was one of the very important purposes, not the only, just one, of the important purposes for the temples at the base of the pyramid, and why people thought slaves were the ones that were helping them. These people willingly worked for those that were doing the work on the pyramids. And there's a reason why. Because if you got hurt, and I can't say any more than that.
Okay.
But we'll do a Rumble show on it. You know
I just want you to think about this, Gerald, because this is how I put it together. Inside the chambers of the pyramid, you have big stones that come up and down. And they change the frequency inside of there, right?
Yep.
So just understand when I say frequency, and then I mentioned shells as transmutation, okay?
Mm-hmm.
Both of those are very much present in there. When I say the Tesla coil pump in there, when I tell you that there's a field being built around it, okay? when I tell you it's based on the geometry of the actual pyramid, okay,
Yep.
every single one of them should be in your presentation.
Yeah. Yeah, pretty close. I don't know about the transmutation of the shell. When you say shell, are you talking about the spherical, like an Evo, like a ball lightning type shell?
So it just grows it naturally in the wall. It basically takes in a bunch of water in there. The water stays in there, so it feels like it's in an ocean under the ground. Okay?
Okay, I see what you mean. You mean like a conical shell, like an actual shell.
Yeah.
Okay. Yeah. That's certainly possible.
The whole thing with the transmutation thing is it's Russell's actual periodic table is now going right through that pump, okay, and going in and out of the top vortex and bottom, and that's what I'm trying to say here. It fits right there.
Yeah. Yeah, you're absolutely right. I'm putting that down as a point in case I've missed it. But I do have something on it in my presentation. But
What I find it absolutely hilarious because we had Bernie over there transmutating things, right?
Yeah.
We have Ben over there working on field. So whether he knows it or not, it's the flow of how that energy is going is the whole rodent coil system, right? Okay. Tells you about flows. It's telling you about the frequency. It's telling you to look for the sound. It's telling you all those things, right?
Yep.
So we got Victor in here talking about fractals and how they work and the mathematics of it. And every single time he talks, it's fitting, right?
Yeah, absolutely.
So, and then all I do is just point out the obvious of everybody's stuff coming together. And this is how I see it. You know what I mean? With all your guys' stuff put together.
I think so. I you know what? I think that, like I said, I wasn't kidding when I said this team, 6 months, and we'll be in the air. And I'm not talking a prototype. I'm talking an actual full working 6 months, a whole crew in the air. I believe that. Because
we already know where to be in the craft. And it's not at the top. Not at all. Nope. So that's the kind of caveat to this is we've already figured it out. You know what I mean? We already know where you have to be and why, and then how we're going to be able to maneuver it.
Oh, yeah.
Yeah, I know you got it.
In fact, we use light to steer it. It's awesome. Wait till I show you the design on this. I actually drew it out maybe 8 years ago, and I didn't quite know what it was for. I was gonna use it for like a go-kart or something, and I thought this is overkill for a go-kart. And then thinking about anti-gravity and getting into all that, it's perfect for a ship. One hand, and it uses light. Very easy. Anybody can steer it at that point. I gotta show you this later. It's really cool. Has to do with like LEDs and a laser. Yeah. So
doesn't Pharos mean lighthouse? Or is it pyramid? One of the words means lighthouse.
Pyramid means light with fire within.
Fire in the middle, yeah.
Yeah.
Maybe it's Pharos or something means lighthouse.
You could be right.
Which makes me think if there was a light that could be directed to power the ship, like we got showed the other day.
Yeah.
One beam towards the ground and one to the sky.
Yeah.
Doing the harp thing, pulling energy out.
Yeah.
I remember that as a vision, that everybody should have a laser and not only own their ground, but own their airspace. And that the laser would hit the sky above their house and bring it back down. And that was, and people were telling me, no, that don't work. But then the harp came out, and it's like, well, that's what they're doing. They're pushing the ionosphere out, grabbing solar energy, and when the bubble comes back down, it's a percentage of return. What they're doing.
Another way that they're doing it too is they're pushing the ground up to meet where that solar energy is, so that it's an easier and quicker marriage between energies so they can pull it out. There's a couple different ways of doing it.
I kind of been feeling that lately. Power lines.
Yeah.
I think they're pulling the telluric current out of the earth. The Mother Earth ain't getting it back. So we're trying to bring the telluric currents up into the air, which is ground level isn't going to be there until the future. So they are possibly grabbing magneto flux from the earth, because every time we close a circuit tries to encompass as much magnetic flux as it can to keep the thing going. If we're pulling it out and sticking it in batteries, the earth's going, oh my God, I got to create more land mass. I just can't recover.
Yeah.
Because they are, yeah.
You're getting it now, Victor. That's exactly what's going on. And
we're seeing the after effects.
Yeah. And we're paying for it. Right? When meanwhile you can have your own plant and not affect anyone around you and grow your own food quick and
So Dollard was right. We're paying to destroy energy.
We're paying them to destroy energy while we're making the energy that we're paying them for.
Well-being.
Yeah. Yeah. Well, that goes to that Rumble show. And yeah, it really goes to well-being. It goes to, I wish I could get it.
Can't say it.
No, because one thing leads to another, leads to it, and it won't stop. So I got to stop.
There's a whole section that has to be
boycott. Don't revolt, boycott.
That's right.
Just simply don't. Violence ain't the answer.
No,
revolt in that sense, I kind of. But
yeah,
the idea of boycotting and just not playing their game and doing what we're doing.
There you go.
I agree 100%. Yeah. Anyone gets hurt in any way, shape, or form, you're already wrong.
There is a theory on how you can topple the entire energy system, the conventional energy system, because it's all based off of money they haven't accumulated yet. It's all based off of future money. They literally reach their hand into the future and they're grabbing money.
That's true.
They got leases, like 10-year leases on these lines, Yeah.
But you'll never prove that because that's a banking situation. You start messing around with their numbers.
But there is a way to crash it, and it's organized payment strikes of your utility.
Okay.
Well, that's boycotting, right?
That's exactly what it's organized.
Guys, I don't think you understand. Even if we could create all this technology, right? Put it in somebody's home. Still going to be service techs. Still going to be maintenance on it. We're still going to have the power company come and check on it. Okay. If you're in California, there'll be 500 regulations on it. Okay.
Yeah.
You're not getting away from any of it. Okay.
No.
All they're going to do is shift it. Now, the benefit to us is the environment itself is better. Okay. We have a lot more good things going on in the environment. It's away from the bad technologies, and we're good because we're not getting away. We're not getting away from the man. Okay. He's going to put his thumb down on us no matter what. Okay.
Yep.
That's not going to change.
If you work with the man, we may be able to get all those added benefits that come
But if
along
the system is made out of a house of cards and you know how that cards is built, you can topple that house.
I don't want to topple anything, but I'll tell you this. If some natural disaster, God forbid, was to happen and it got toppled, I'd be right there to pick up the pieces.
It's in a metaphorical sense. You're taking the money out from under them, basically.
No, I get what you're saying.
Okay.
But there's enough money to go around, like Nathan was saying.
I do not want the energy company coming after me.
Yeah,
so I will not talk about toppling them because I do not want that.
I don't want to.
Sorry, I don't want any part of it. Okay.
Yeah.
I don't even want to have that discussion.
Yeah.
So that's the whole reason. They come after you and your wife is over there in the black dress. So I'm not doing it.
I'm not advocating for it. I'm just saying it's possible.
But I believe that there's enough money to go around. I also believe that if this tech is proven to be feasible for all, that getting it into the hands of everybody, working with some of those companies would be a benefit to those companies and to the people. If it's not a benefit to the people, find another company.
Well, hold on.
You know what?
Once
You know
this
what?
tech is,
Go ahead, Nathan, and then Mike right after.
Yeah,
go ahead, Mike.
Go ahead. No. Go ahead, Nathan.
What I was going to say was once this tech's out, they're going to start talking about rejuvenating Mars because it's the absolute thing you're going to need to do it, and the understanding you're going to need, and a big moon, maybe a cat. Yeah, might need a cat over there.
I got a few. Let's see. Maybe this one wants to say hi. Say hi. You say hi. Just want to say hi. I'm sorry.
Go ahead, Mike.
Yeah, personally, for this free energy stuff to really come out in full force, I'm a sole believer in decentralized power, because the centralized power system that we have today, there's very little redundancy in it. Perfect example of that. Remember the great blackout of 2003 where the whole eastern seaboard went into a blackout?
Mm-hmm.
Basically, all the way from Canada, all the way down to Georgia, and I believe into Florida too. So that's a catastrophic failure. Now, just picture in your mind if that was permanent.
That's when it's time to come up with this tech and give it to everyone.
No, but I think 2003 was a wake-up call that what will you do when the lights go out and they're not coming back?
Yeah.
Because the centralized power system fails. Say we get hit by a solar storm that takes out like that small city in northern Montreal back in 2012, wiped out their power grid for 3 months.
Yeah, true.
So, we're sitting duck. Do we have a centralized system that can handle a massive failure like that? And the answer is no, we do not. So I think in the not so distant future, people are going to look, even governments are going to look at the possibilities of decentralization of the power grid. Because we're sitting duck. We get hit by a solar storm or we get another Carrington event, we're screwed.
You're right.
Think about it. If the power grid goes out, how many nuclear power plants are in North America? Say there's 200. Well, guess what? Now you got 200 Fukushimas going off at the same time.
Okay. Now that you said that, I can say this. And it'll be part of the presentation. But I believe that this tech pulls the energy out of particles and drops them down to their daughter form or their sister form. Call it what you will. So what does that mean? If something like that was to happen in a catastrophic, crappy scenario, I believe that this tech would help everyone because it would pull the energy out of the air that's hurting everyone and allow you to use it while you're grounding it out.
Right.
Fully believe that.
Now, okay, say your theory is correct and say you're able to make a machine. The thing is, from now till then, we're a sitting duck. All the power goes out. We got 200 Fukushimas happening at the same time. That is a global, not just a local, we're talking global catastrophe. All that radiation is now going to be in the atmosphere.
Yeah.
We're talking Earth-ending event. Okay, look at
but in that case, it doesn't. Hey, if that happens, it doesn't matter anyway. What tech you have is, regardless, you'd be done. So the whole world would be done. Even if you were to save yourself, who else is there with you?
So that's why my belief is that we have to go to a decentralized system. So a Carrington event happens, we can deal with it. right now we're a sitting duck.
You're not
we
wrong.
truly are. So between now and then, what's the world going to do about it? Are we going to be
Who
complacent?
knows?
Are we going to be complacent and it's going to happen? And then guess what? Well, it's too late, right?
Well,
Well, when the next blackout happens, people are going to be turning to us for solutions, for real solutions.
that's if
But no,
you're. Go ahead.
what I'm getting at then is the fact that if we have a Carrington event like we did in the 1800s today, we're done. We're finished. We're talking global catastrophe.
Yeah. And at that point, it doesn't matter. Have a Coke and a smile and call it a day.
That's it.
Because
my
what else
my
can you do?
parents are caught up in that hurricane right now, and I'm sure they could use some kind of system, a backup system for their power, because it's going to go out.
Right.
Yes, I
So
hear that.
that's why I'm saying a decentralized energy system in this day and age, it's a no-brainer. The centralized system that we've had for the last 124 years, that day is coming to an end.
Yeah.
If we don't evolve to the next step, we're not going to evolve. We're going to go extinct.
Yeah, something tells me they're not going to get into that. They're trying to unify the world right now with all their policies. They haven't figured out how to make it work yet, okay? Because they can't unify all their laws throughout every single country. And until they do that, it's not even a bother to try. So once they do that, the borders are going to start to go away, and it's going to end. They're going to take everything. It's just the way that the government works.
They're trying.
Well, just look at what Reagan said. I believe it was Reagan. He said, imagine how quickly our differences would dissolve as a world, if we were faced with one threat from outside the world. So
Okay, so you saying that makes one wonder about a lot of different technologies that they have going on. They don't tell the people about. Like
it raises a lot of important questions.
And blue beam. And when it comes to weather modification, I got a website right now that literally out of Israel tells you exactly how they're doing it and how they make it rain because they need rain in the desert and they're rebuilding it or whatever it is.
Terraforming or whatever, yeah.
Yeah, but they're not hiding it. They talk about chemtrailing. They talk about silver nitrate. They talk about how they use ionization of the air, and they use pyramid-shaped antennas, 8 of them, that pushes off ions into the air, and with the silver nitrate, allows it to rain.
They're cloud seeding.
Nation's real. I don't care what anyone says. I know that for a fact. It's real. A fact.
Here's a weird one. Someone just posted a video that said Nikola Tesla is not who you think he was.
Yeah, I seen the title. I didn't watch that video.
It's like only 6 hours old. Apparently, they're trying to say he may have been Illuminati or illuminated. I don't know. I haven't watched it, but it just got released.
It wouldn't surprise me. I was told at one point Nikola Tesla had the access to the Library of Alexandria, which was never burned. It was stolen and hidden and kept with the Freemasons, passed on through generations, and they each have like their own library, and there's information in there that you and I can't even think of, can't even fathom, because it's been there for so long.
It'd be interesting to look at.
Yeah, definitely. And the rumor is that Tesla was into that library, and it led him to the Pyramid of Giza, and he was fascinated by it, and that's how he was able to find his tech. So
wasn't his father a Jesuit priest, and his mother was like an educator in her own right? So
yeah, and the Jesuit priests were essentially pre-Freemasons, right? I don't know how to put
he was
that.
educated, and I personally think he was brought in to reverse engineer stuff because of his connections and brilliance.
That'd be interesting. Yeah.
Maybe. Yeah, that's definitely a possibility. Because he came from another country to the United States to get things running.
And he had a letter of introduction saying, yeah, this man is on par, you know, kind of like an introduction saying, hey, I heard you guys need someone. This is the man I recommend. So I think he was reverse engineering.
Maybe.
And since it was owned by all of our, leaders and such, he kept his mouth shut. Because you notice he got shut down after Einstein came up with his general theory and steered the ether out. And yet, if you look right at the symbols that Nathan has of the Jewish rings, the very first one is called Kether. Well, take the K off, that's ether. They knew it existed, but it was obfuscated.
Yeah.
You know,
Yeah.
and what happened to him? He started, in his end of his life, he was almost like, oh, I got to try to get everybody's attention back. And he started designing weapons. That was not his way to begin with. So
You're absolutely right.
something changed in him.
That's interesting. I never considered Tesla like that. I'm going to have to actually look at things in a little different way. Because, you know, if you look at it like that, some of his inventions make a lot of sense. You got me thinking again, Victor. I like it. I'm going to have to watch that video. I have that video on my feed, and I didn't look at I seen the title, but I didn't watch it. That's interesting. I always wondered if he was a Freemason or connected there too.
Yeah, that'd be definitely interesting.
Yeah. Yeah, it would change a few things, wouldn't it? Because if he was a Freemason and he was reverse engineering, that means that this tech's been around and they've known it for thousands of years, or hundreds at least, right? I don't know. I don't think that lightning rods were meant to allow lightning to strike your house and go into the ground without causing a fire. I think they had another purpose. And I think Tesla was part of that purpose. I think they're actually static collectors for energy in your house.
Well, it would seem that this is destined to come out anyway, because he did state that the work I do today is for the future.
He did.
He knew
That's
there was
right.
going to be a time it would be needed. And I think that time is now, if the golden age is going to start with not come in with a glorious bang, but be cold for a while, if the yugas repeat themselves. And the way the weather's going, something.
Yeah. We're coming above in this plane. This is what I was shown. We're coming above the what's the word? It's like the mid plane, like we're coming above a event horizon. So if the center of our universe is like a flat plate with a tube in the center and two poles, we're coming, because we go around it like we go around a wire. We go around this whole plate like going around a record player, and it's up and down as we're going around. Right now we're coming at that top peak. We're just starting to come up to that peak. So if the yugas are correct, yeah, we're coming into a positive yuga right now. So interesting, by far. What I was shown was, we're coming into some heavy times in the next little while. People aren't they can't fathom what's coming. They don't even expect it.
People who are sensitive to it can pick it up, though. They know.
Yeah, okay. You're probably right. So we're going to go through some shit.
Yeah.
But then at the other end of that shit, we're going to come out and it's going to be the sunniest day you've ever seen. Kind of like the breaking of the golden dawn. Have you ever heard of that? The golden dawn? That's apparently some form of a Freemason thing too, right? I don't know. But
Well, this age of ignorance has gone on long enough. That's all I got to say.
Yeah, well, we've been lied to a lot, right? And I don't know, what is it? Did we accept the lie and that was the problem?
I think for a while we did, but people
No.
are starting to not accept it anymore.
Well, I'll tell you what's there's one institution that's lost its grip on power, and it's because the United States was created. And because of that, the secrets are coming out. Okay. So
Yeah.
they used to burn us at the stake for it. So now they can't. So now they lose power.
You're not wrong.
That's where all the secrets have been stopped for hundreds of years. And now they can't do it anymore. So
Yeah, there's too many people that they'd have to burn at the stake.
Yep.
And information, it travels too fast in this era. You know, you put something out there and it's everywhere.
Yeah.
That's how they controlled us. They kept a cap on it. That's how they controlled the Bible and put in what they wanted to put in. There's chapters missing in the Bible that should be in the Bible.
Yes, there is.
There's probably things in there that shouldn't be in there because
Yes, there is.
Jesus does not believe in some of this stuff. Okay.
Yeah.
You do not go to church to hate. You do not go to church to hate people. Not in any reason, shape, or form. And if that's what your church says, you're wrong.
Although it does say in the Bible that God hates those that do things in secret. It does say that. So are we taught to hate? No. But those that do things in secret are doing things behind your back for their own benefit. Don't give a shit what happens to you. So that in itself is a type of evil.
Yeah, but they take that the wrong way.
Yeah. Yeah.
They think of what people do in their bedroom versus them hiding secrets and screwing people over and taking their wealth.
Yeah.
There's a difference
that's
there.
a good point.
So if God came back, I would like him to go get everybody who takes people's identity and take care of that business for us. That would be nice. Okay. What you do in your bedroom, I could care less.
I'll ask him to put it on the list.
Yeah.
I'm kidding.
Hey guys,
I'm going to get it for that one.
I got to head out for the night. Thanks a lot. It's been a great show. Thanks for having me on, and we'll talk soon.
Right on, Mike. Thank you very much. We'll see you on Friday.
Yeah, thanks, Mike.
Sounds good. Take care.
Have a good one, Mike.
Take care.
All right.
Yeah, I think it opened the floodgates for everything, and we're now able to do all this stuff. So
this free entry. Go ahead.
I just don't know. Society's having trouble coping now. Okay. And I honestly hope it doesn't come to the bad stuff before we get to the good stuff. You know what I mean?
That's what I fear.
Yeah, me too. I fear the same thing.
You know, I just realized, though, I keep kind of feeling like most of the establishment is like screwed us. But in an essence, maybe we're all here on the internet. If it weren't for the internet, we could not spread this word so vast, you know?
Just like Nathan said, they screwed themselves.
All of everything is bad.
Yeah.
You're not wrong.
Their tool of control has turned into Achilles' heel, essentially.
But the internet is
it's meant to be. It's just there are.
You think that's by design?
Darkness, but you can't have light without dark. So both of them have to learn to work together somehow.
Yeah, it's a double-edged sword. Think of it like that, right? Sure, we get to put out our information, and people get to see it, and we can spread it far and wide. But it also gives those that are watching that we don't want to watch, telling them everything that we know.
We're supposed to love thy neighbor, even if they're evil, right?
Yeah. You're supposed to pray for your enemies.
The thing is, it's just going to confuse them, Gerald. Like you said before, they won't get it. Because they can't get it. Because their mind and their heart's in the wrong place.
I could give you an example, but individuals that are watching are part of this example, and I don't want to insult them or, piss on who they are or whatever. So I don't know if I should give that example, but just recently there was infighting in a group that didn't need to have infighting. They're all working on the same thing, just from a different angle. And I've watched it played out. So were they my enemies? No, but they're definitely going against what it is that we're doing. And what we're doing is trying to get this tech out. Well, I believe this tech was given to me by Jesus Christ. And I believe that getting it out is more important than me and my life. So if these guys are going to come against that, all the power to you, but you're not coming against me. I don't give a shit. You're coming against the one that asked me to do it.
Man, it's
So
not
good
my
luck
truth.
with that. What's that?
Something I've been realizing is it's not my truth.
Yeah, it's not mine.
It's my
No.
truth. So
I'm just a vessel, man. I'm just a voice.
It doesn't belong to anybody. It's supposed to be available for everybody.
Exactly. It
That's
wasn't
how I
given.
see it.
It wasn't given to me to keep. It was given to me to give.
To
It was
pass on,
freely
yeah.
given to me. It should be freely given to others.
And I like your idea of trying to find maybe at least one or two, people to try to teach this to once you've got it. You know what I mean?
Yeah. Yeah.
And you don't have to put it publicly out there, but at least teach one or two people,
Yeah, and if you teach two friends, and they teach two friends, and those friends teach two friends,
Yeah, pay
you know
it
how that
forward.
works.
You just
Yeah.
pay it forward.
Yeah, absolutely. And then everybody has their own systems. And we don't have to worry about the grid going down. Doesn't mean bypass the grid and screw all the companies. That's not what I mean. But if we all each individually had these systems sitting in our house and the grid went down, flip a switch, man.
Yeah, most people don't have a contingency. Like, they don't have a backup system they can just pull up.
Yep.
Those things are very expensive and costly. Most people can't afford them, but if we can give them a simple, easy, cheap solution, that would save lives. It really would, especially in the winter and in times of emergencies.
Absolutely.
now I'm seeing where the battery charging system could actually be useful since I have radios and only one battery. We need to start making some changes.
Mhm.
There you go.
The wheels are turning tonight, gentlemen.
They are. They are.
The
I
wheels
can't
of
wait.
destiny.
I just warn you, no matter what comes out, it's going to have to move a little slower to get to the market because it can't go right away.
Yeah,
Even if the understanding is out and you can build it at home, it cannot reach the market. And I'm sorry to say that, and I know that's
No,
bad,
you're right.
but we need society to be as a whole and in good shape. And I'm not willing to have chaos in order to get it out there. Not like that.
Yeah, any
It's
big
pretty-
disruptors. Yeah.
Not
Well,
like
too
that.
innocent
We have to
people.
do it ourselves because in order for it to be a product, it has to go through years of research and safety precautions and get UA labeled and
Yeah.
so it has to be a self. Oh yeah, okay.
Yeah, so what I'm saying is we're not trying to change any system, but
Trying
for
to add
us to be able to have the technology to do it, because to be honest with you, man, I just want to cruise around Mars, once or twice, take a look, see the pyramids, you know what I mean? Go on a joyride and
That's
maybe
where
see
our
the rest of the
destiny
solar
is, the
system and
stars.
come home.
Yeah,
I always
we're
thought I'd
supposed
have a
to.
hot
We're
dog
supposed
stand
to.
on the moon. Sorry.
Yeah.
I'd like to have a system to come buy your hot dog from your hot dog stand on the moon.
Yeah. Give me a
That's
cold
awesome.
Heineken. Yeah.
Moon
Right.
dog.
That's awesome. Yeah, I'm of the same mind. I just want to, I want to fly. Before I die, I want to fly. That's it.
Yeah, see something cool
Love
like
the trees,
That's why I got into video games.
Yeah. Yeah.
The feeling
then
of
you can
life
go
is
over.
so
Yeah, you can see the land. You can see the waterfalls and places
That's
nobody's
why I like
been.
No Man's Sky. If you've ever played No Man's Sky, it's a great game for that. It's all procedurally generated with math, so it's not like it's a set artist who made like this planet. It's all procedurally generated, so it's using simulation, to generate the different fauna and flora. It's really cool. From a science aspect, yeah, it's really interesting.
What's that play on?
That
computer.
All the consoles, yeah, and it's crossplay too now.
Nice. Writing notes. Nathan, you've been at it for 4 hours and 20 minutes. Are you sure you want to keep going much longer, brother?
Yeah, I'm good if you guys are.
420.
Looks like a couple of us need a break.
Oh,
I'm out. I'm taking a break from it for a while. I realized I probably should clean up my system a little.
Yeah, detox is always good.
It's stressful too, but I'm pushing through it. Praying.
very cool.
So, yeah. Are you 420?
Yeah, Taryn, you ain't kidding. I do. I have a bad sciatic nerve from a fall I took collecting a bonsai tree. I ended up bouncing off rocks and got nothing but a stick in my hand when I was done. But it dropped something.
Yes.
Well, at least
Very
you got
cool.
something.
Huh?
I said, at least you got something out of it. Yeah. I wish I could say more about back issues that I had, but we'll have to do an episode on Rumble about that.
God, man, I could use that right now.
Yeah.
I'm definitely feeling it today.
I'm telling you, I can't wait till we do that Rumble. There's some things I can tell you that would help you so that when we exchange things, yeah. Say no more. It's hard, man. It's hard to keep emotion on that. That part gets me really excited. So,
Well, we should do that. I don't know how to do it, man. We're going to have to make a complete version and then an incomplete version once both of ours come out.
yeah.
Then, you know what I mean? That because there's going to be a whole lot more that's added to it based on what we're both bringing in. You know what I mean? So,
Yeah. Okay, I know what you mean by
and
that.
then when everybody else gets to chime in with it, there's going to be so much more. So, say for instance, you give your presentation, right?
Mhm.
Victor gets a hold of that presentation. He's got to add to that presentation, right?
Yeah.
And then I'm going to add to that. Okay. You know what I mean? Ben's going to throw in his, and you know what I mean? And then Bernie's going to come over and just blow our minds. You know what I mean?
Yeah.
And we're all going to be singing the Pineapple Song for about a month until we figure it all out. And then when we're done with that, we'll have the right theory.
You're right. You're probably right.
Because it won't happen by just one of us.
No.
And I guarantee you, Sean's got something up his sleeve. That ball Tesla coil, it's so much more important by what it does. He's putting out I don't want to say this, a magnetosphere field in the geometry that it's doing it at. Okay, it's so interesting, and it has to do with the cavity in the center. Okay, because there's nothing in the center, because it has a north and south. Okay. It's
producing a ton of high voltage. So if you were to take his high voltage, put it in to my coil, and get the original power from Mike's battery, you now have a system that'll run forever for free.
But check this out. The only way that thing is avoiding everything in the room, okay, when that energy comes out, is it's either cold electricity coming out of it or it's pulling it in. Those are the only two ways that it happens. And if the ground is pulling it in as well, which he did show, okay, that he pulled in a spark this long from just putting it to the ground cable, okay, and it's sucking into the coil. So you could have both sides sucking into the center, and that's what's creating the null zone in the center, okay? He has a resonance chamber in there. It's totally mind-blowing what he's got going on.
That null zone is important.
Yeah.
Yeah.
He mapped it, and he showed the null zone, right? That thing literally, you know what I mean, is part of the puzzle right there. Because
the null zone, go ahead.
No, I was just going to say, because you have a mini Tesla coil in your coil, okay, because of how it resonates.
Yeah.
He has a Tesla coil showing the same effect, resonating in different geometry. Yours is creating the geometry of the field based on the wires going on a two-dimensional plane, right? He showed the same thing in a three-dimensional plane in order to show the exact same thing. So when you have cavitation, just understand this, and you have a cavity, if you resonate that cavity, there's a reason why they put a metal bell over the top of it. On every single ancient site that you see, you'll see a cavity on the bottom, you'll see a bell on the top. There's a frequency on that bell, okay? Every single one of them has it. They knew the resonance frequency of that. They knew the resonance frequency of caves and stuff. So when they start telling you about, oh, in ancient Greece, we got a cave that, did this and that, well, that's because that's what it did.
Yep.
Go ahead, Victor. I saw the face.
Yeah.
You just made me realize something. You know how I've been showing that VCV rack?
Yeah.
The synthesizer that you can patch cable up all the stuff?
Yep.
Yep.
There's a brand new unit that I'm looking at getting. It's going to cost $30, so I'm kind of waiting. They just put out, I guess, I've got like a demo of it. But anyway, it allows you to create a room of any up to 300 by 300 by 300 meters down to, I think, 2 meters.
Mm-hmm.
You can set sound sources and microphones in the room and then play your tones and get the oscillation of how that room would echo and reverberate. So I'm thinking of putting in pyramid dimensions into the chamber and checking some stuff out. Not quite sure where to put the microphones yet, but I'm thinking the niches in the walls might give us an idea of where. But anyway, there's a demo of it, and yeah.
That's interesting.
It's not a free package, so I'm waiting. I'm thinking of getting it and checking out resonance of chambers. But yeah, it's for that package.
There you go.
You guys are making me want to bust out my guitar and pump it through the coil.
I've done
What you should do.
I used to do that.
Sounds fun.
Yeah, I pump music through the coil, and I don't do that no more.
Yeah, it's too many frequencies.
Your coil is another level.
Yeah, I get some things I don't like going on. I don't put music through it anymore. I'll tell you why later when we're not on air.
It's just too sensitive, I guess.
You become sensitive. Music affects the body, remember that. Right? So if you're putting music through a system that could project in a way, then yeah, might affect you a little. Might.
Dissonant music would really
Oh, you know what?
with your emotional state.
I can say this. There's a frequency, and I'll never give this frequency out. I found it by accident. And
the devil's tone?
Yeah. And it's like everything in you, every cell in your body is dying at that second. Never play it again. Ever.
Nope.
No.
Oh,
I'm telling you.
Gerald, I'm sorry. That shape we were talking about, and I won't mention which one. Okay, the odd shape.
Yeah.
I read up on it and what they said that they thought it was. Okay.
Oh yeah.
And it says like different stages of emotions is what it's going through. Okay. It's it was interesting as heck. They had a whole bunch of literature on it. Okay. On that exact shape. Okay. That just one oddball shape. Okay.
Really?
It was fascinating. I'll have to send it to you. There's a whole bunch of it. I can link you to the site and you can go through it and look at it.
Definitely do that.
Can I get that one?
Yep.
On the forum that you're talking about?
Nathan.
Can you send me that one too?
Oh, yeah.
With a side of fries.
Yeah. Well, it was just so interesting because, well, I shouldn't say any more about it until Gerald's done, but I'll say this. Everything that Gerald talked about on the side that we can't talk about has to do with this right here. And there's actually a tie-in. There's a whole thing to it, and it has to do with this one. And then they showed a really cool graphic, actually. So they showed this thing right next to it that was spinning, and they showed a triangle on it, right? So every time Gerald talks about his coil and what it's doing, he's telling you there's dimensions in it, right? It just reminded me of that. That was it on that little part that was in a caveat next to it.
and it's funny because that part matters, and I have medical papers proving about that subject. Okay,
Yes.
you know what I mean by that?
It's so hard because it's totally part of what you got going on. It's like I don't know how to say it without saying that
Without
part.
giving it away, right? Yeah, and it has to do with in the long run, it'll have to do with gray hair and all kinds of things.
It was just the craziest thing, and it's something that you totally wouldn't think of in any way, shape, or form.
Right?
So
This came from. Go ahead.
I found it by continuing to wind until I found every geometry that made sense. Okay, and then the exactest. Well, let's just put it this way: I'm kind of a nerd when it comes to that. When it comes to geometries that I like, and I will sit there for hours after hours after hours and figure them out. Okay, on exactly.
I can say one game, and I'm positive you'll know what it is, and I'm sure Victor will know what it is, and it'll give you a darn good idea on some of the shapes that are going on. Spirograph.
Can I show you something real quick?
Remembered.
But that makes sense.
That?
That's why you're so good with the 3D printer and customizing your parts.
Right? So Spirograph, for anyone who doesn't know, was like a game board kind of thing, and it came with pieces of paper, and it had all these little plastic things that you'd stick they were different shapes, and you'd stick your pencil in the hole.
Yeah, and you'd spiral around.
And it would form these wild patterns and shapes, right?
Pencils. My sister had those. That's right.
Okay, well, that kind of, there's a lot of shapes in there that are involved in these coil systems. If that
Those pencils are really cool.
No, I just watched that. The guy was making the whole thing of life, that seed of life, right? There's frequencies everywhere in this thing.
Flower of life? The flower of life's in there.
Can I show you something on the sun?
What's that?
Yeah, go for it.
Wolfram Mathematica that I've been showing you. Since you mentioned patterns and
Spirograph. It was a fun game.
Parker spiral polygons for the solar magnetic fields. As you change the number of sides on the polygon, you affect the sun. They have found this, you can look this up. Some scientists, I don't know who, have found that they can cause disturbances on planet Earth and get an effect on the sun. So there's some shit going on that's. But you said spirograph and the spirals. Yep. This is an approximation to solar magnetic field geometry on a solar system. The lines are imaginary visual aids akin to streamlines that help us understand the structure. It's called the interplanetary magnetic field and has characteristic angles with respect to the sun-planet line. So each planet has a different line, and you can change these angles and the three-dimensional tilt of the system, but you get perturbations going on. And
I'm hopping out of my seat here, Victor.
What?
I said I'm hopping out of my seat, man. You're confirming everything. What if I was to say to you, okay, here's some woo for you. Here's a thought experiment for you. What if I was to say to you, there's a coil system that could travel you between each planet? Between here and another planet, between that planet, another planet, another planet, another planet, all based on geometry. Not only that, what if I was to say in the woo, in this thought experiment, that the sun wasn't what you think it is?
It's not.
And it is a possible door to another.
Remember, Saturn used to be a star. Something happened and his power got usurped and transferred to whatever star we have now.
It's some woo, I'll tell you that. But I don't release everything I was shown. And the sun is very important. So if you can affect the sun from here,
that's scary.
It was a door. Maybe you have a key.
it says in the Bible there will be one that comes that has the keys to the gate. That's what makes me leery of saying anything, because if they don't open,
they ain't got the key.
Birkeland currents. What if we were to all of a sudden open the gate, that little pinch point out there or whatever, and it triggered something, and the gate didn't open to the sun? What if it opened to Saturn, or something that's not hospitable? Or
that what you're talking about is geo. Hang on, it's coordinate important in the sense where you couldn't open a door between here and Mars if, let's say, you were standing in Florida. But if you were standing someplace in the north, someplace very specific, you could open a door to Mars. So if you were to go open a door to the sun, you would have to be in a very specific place. And there's a reason for that. Right? So I wouldn't worry about whether or not you would open up the wrong door. More, I'd worry about being in the wrong place when you open the door. So if the wrong place on the planet, when you open that door, would bring you to the wrong spot that you didn't want to be in. Right? Do you know what I mean by that?
Yep.
Like Birkeland currents go from point A to point B. Well, so did these ways of travel that we don't quite understand. But there's an anchor point. There's an anchor point here.
Angkor Wat. Anchor.
What's that?
Angkor Wat, the temple.
Yeah. I'd never brought up Angkor Wat. Yeah, that's interesting that you brought that up. You're just confirming everything that I've been shown and taught. I'm telling you right now. So it's possible that the sun is actually a door and that we go through it to another space. I don't know. I don't know that much. I just know what I was shown.
I hope it's a door, because if it's not, I don't want to be there.
Well,
might be a little hot.
He left the door open, and he knows we have the ability to open it the rest of the way.
Well, I would think of it more like along the lines that you can open the door. No, you can't open the door. You can only open the door if you have the proper genetic code. And that code was given to you on the day of your birth. But due to everything that's going on in the world, our codes have been shifted slightly off. So if you were to go through, say, a system that brought your DNA back to its original form, you could walk through that door as if you were walking through the door in your bedroom, and it wouldn't affect you. Whereas if you didn't have that genetic code and tried going through there, you ain't gonna make it.
Got a point. Noah's people were saved because their DNA was not tainted. That's why when shit started happening a while back and they were getting everybody wanting to, play a game with them, I was like, hell no, you are not tainting my DNA with that shit.
Yeah, I don't play games.
Okay, we're going to move on to something else.
Yep, exactly.
There we go.
But amazing, all these tones and colors that come together, right? Because those colors with those
Sign has
tones,
a color?
every tone has a color.
So it's not just that, it's the ages that we're in. It's showing you of a calendar. So it's tying in like 3 theories in one, maybe more. That's why I thought it was interesting.
Sound, light, and vibration. What light? Color. What's color? Well, it's a shade of light.
Yep.
Huh.
Not only that, you look at the symbols, right?
Yeah.
Well, they're your star signs, the planetary. So can you zoom in? I'd like to kind of read Cancer and see what it says.
Where's that at, top or bottom?
An A, huh?
Oh, right there at the
F
bottom.
minor and A flat? Or A sharp? I'm not much of a musician. I play, but I don't read.
Yeah, I hear you there.
I just thought that was pretty interesting, and it was a great segue to get off the other subject.
Yeah, we get a
I hear
little
you.
excited occasionally. Sorry.
It's hard to pull away from that, but you're right. Yeah.
Oh man, when you're compelled, it just pours.
Exactly. It's the
And you
flow,
got and
right?
but we're in a establishment, yeah. So
Yeah. We can only go so far.
we have to rumble in order to.
Yeah, we have to. That's. Let's get ready to rumble. I had to do that. My cat didn't like that, I'll tell you.
Yeah.
He's looking at me like I'm nuts. Well, that's probably partially true. Anyway, talking to a cat, of course, it's partially
Major.
true.
Okay. Thank you, Kute.
Yeah, I don't know how to pronounce that person's name. Quadrin? Quad-10?
Quadrahedron? Is that what you're talking about?
Maybe, I don't know. See, and what if sound was the thing that opened the door? Resonance is just a way of vibrating, or how do I put that?
Well, don't some
Sound.
religions sing? They don't speak their verses; they sing.
Yeah, in
Because
melody.
it's very hard to lie when you're singing.
Yeah, even Jesus Christ was known to speak in melody when he was speaking in parables. Why is that? I wonder, right? Because everything's a tone. Everything's a
There's the hypercube.
Yeah. So
flow.
Oh, wow.
Go ahead.
geometry and dimension, from flat geometry to 3D shape geometry to the fourth dimension of geometry, okay, to the field of geometry. Just throwing it out there might be important in some way.
What's that very bottom row?
So
wireframe.
Oh, that's wireframing each one?
Yeah, hyperspherical.
Hyperspheres. Well, that's where you're getting into the molecules being shelled and wrapped up then. But they're not molecules, they're the vortices.
I know what you mean. Vortices creating mass, therefore looking like a particle or becoming a particle.
It's a Wolfram, ain't it? Yeah. No?
just something that might help you, Gerald, if you look it up. It's something interesting. They just talk about shapes, geometries, mandalas. You know what I mean?
Yep, I do know what you mean. I know exactly what you mean. In fact, I know these patterns.
Those mandalas have a lot more information if you know how to read them.
Mandalas are exactly that. If you know how to read them, they're data collectors. They're like they're like a QR code.
Yes,
that's exactly what they are. They're a QR code.
So when I show you the shapes and dimensions like this, you have to start thinking of field, frequency, stuff like that, right? You're going to have to really put all of it into this to understand that mandala. Okay? Yep. And each one of them presents in a different way. You know what I mean? Straight lines is the building. You start looking at that. Then you go on to the bent line. What's the bent line? That could be the frequency. Then you go on to the next line. Because it's overshaped, it's the field. There's a ton of stuff that goes on to this on just the geometry side of it that shows up in every one of these coils.
Absolutely.
Thank you. You just gave me a presentation.
Well, you're welcome.
Five things out of Wolfram, and I can put them in a row and help explain some of what we're doing to people that I think I have 5 in mind.
We're all getting on the same page without saying everything.
Yep. Absolutely. And what if these
2 of those
shapes
3 of
represent?
Them.
Go ahead, Victor.
3 of them bottom ones look. The first, the third, and the last seem to be
similar.
Like Shawn's coil, it makes patterns, and they seem to reveal a connection.
Interesting.
The first, the third, and the last one.
Well, hold on. Let's zoom in on the bottom then.
Yeah, I'm trying to read it, but okay, hyperspherical. One's a projected. Okay, perspective projection. I call that shadow tech, where you shine a light through the object and see its shadow. or projection. Okay, I thought it said wolfram. It says wireframe. Okay. Oh, well, that's, wow.
Yeah, that's interesting.
I'd like to see the crochet in the middle. That would be. Yeah, I see Bernie, finally. Dude,
Hey, Mark.
you did a
Well-
presentation with, I think, Dutch Sense, and you guys were looking at star forts.
Yeah.
Yes, sir.
In it, you showed a guy that had some kind of weird little scope, and he was mixing triangle, square, and sine wave to get a star fort pattern on the scope. You recall that?
Yeah, Campbell showed that video. I'm not sure where it was originally from. I'll have to look into that for you.
That when I saw that, and my fractals, I mean, one of my pages, I said Padavans triangle numbers, golden ratios square wave numbers, and sine waves are pi based numbers, and the math was right there. And then when you showed how that three mixed and made the star fort, it kind of triggered and blew my mind. And I was like, dude, we got to hook up. But you have so many shows lined up, it's hard to get in your playlist.
It's true, but
If you find
here we
that,
are.
we could do a
And-
show. Me, you, Gerald, and
Absolutely.
Straight, and Nathan, and just tear that down.
We will
Pound
have
it
to
out,
do
get
a
it
do a
out there.
full one on it for sure. I'll look into it and try to find the original guy because he does several experiments with it.
Okay. That he's got something.
Definitely. And
All right, guys. I want to. Sorry.
Yep,
Go ahead.
Go for it, Gerald or Nathan. It's all good.
Just wanted to share this to see what Victor thought about it. It has to do with the patterns.
Nice.
If I'm not mistaken, we're talking about alchemy, but we're also talking about fractals.
Well, it's a periodic
Yes.
table going Celtic with something like a dollar sign in the middle. Or is that the three pillars of anyway?
I'm just looking at the table that they created and the patterns that they created in that table.
There's a few angel sigils in here.
There are.
Yeah.
Yeah,
That's-
I don't know. It looks very interesting. Like, I think that top row, not Sanskrit. Oh, man. What was before Sanskrit?
Oh.
Or after Sanskrit? That top one looks familiar, but the problem I have with those kind of things is you almost have to go and become a student of whoever, and spend some time
Right.
doing that and see whether or not you find out you already knew it or it's bull. Or
Yeah.
in memory of the dead twin informants? What? Matter equals water. Oh, maybe it's Irish. I don't know. Black alchemy chart.
Like I said, I could care less about all the writing on the page. I only care about the patterns on the chart.
Right. It's more like they're pieces of a maze.
Very similar to a lot of the symbols on my buddy Mike's artifacts, alien carvings there out of Mexico.
I mean, you've
Very
got a
interesting.
Yeah, he's got some.
Star of David. 6 different states of the triangle.
Nathan, what Bernie just brought up,
Yeah.
I believe the guy that the guy that Bernie's talking about, some of the artifacts that he has directly connected with this,
That one.
and it may be hundreds, if not thousands of years old. Some of the stuff, it looks like he has, And I don't know. It's interesting.
Well, there's a ton of shapes that keep coming up no matter where you go, and it's redundancy.
Some of them are ancient.
Yeah, well, you got to start seeing patterns and everything, and if you start seeing the pattern and everything, then you can see where it goes, okay, and where it followed, okay. Then you can understand why the lines are there, what it correlates to. Have you built any fractals for radios that look like any of those? Okay. There's different things that could be going on there that you know, transmutation that goes on when you do it. It's an alchemy chart. You know what I mean? It could be a basis for an energy pattern of accumulation resonance frequencies in order to make it like an early Russell table before Russell came out with it.
Yeah, I know what you mean.
So this one I've shown a lot, and this is like the official alchemical periodic table, kind of similar. And I have said from the beginning that the shapes are representing like energy vectors and connections in the geometry of the elements.
You're right. And I know something about this, but I don't want to talk about it too much because it's borderline witchcraft. But you need 3 components, not just one of these symbols. You need 3 symbols, and you got to take it from all of this chart from 3 different areas, and you got to overlap them. When you overlap them, they become something else.
Interesting.
Yeah, I studied the bat, unfortunately, not to become part of it, but to understand what it was I was looking at, that all these people believe in. You know what I mean? Know your enemies better than your
right?
friend.
Yeah, I've been doing the same.
Not
and
that they're enemies, but you know what I mean? Like
your adversaries.
I guess you could say it that way, yeah. I don't know. I don't have enemies and I don't have ill will towards anyone. I don't hate anyone. I hate those that do evil, knowing they're doing it, enjoying they're doing it, and purposefully doing it. Those people I do hate. Why? Because it's written that God hates them, and I hate who God hates. Sorry. That's just who I am.
Yeah,
Get wrong. I could be proven. What's that?
Nothing wrong with that. So I figured I'd share this one with going into the oh my gosh. Yeah. Mandelas. There we go. And showing the Om sound on a tonoscope identical to the Sri Yantra Om Mandela. So they knew exactly what they were putting into these.
Absolutely, they did.
Yes, they did.
Yeah. Yeah, they're showing cinematics at the original, like right from the beginning. Basically, that's what it is.
Yeah.
Yeah. Yeah, they knew about sound.
They knew a lot about it.
Yeah.
So it's like, are these circuits? Apparently, there's one that's Mandela that's made out of gold flake that Charlie C was talking about, telling us a while ago that it was documented having like radiation coming from it. Like it was generating radiation out of it.
Well, that square one?
Not sure if it was this one or another one. I'll have to.
I've seen that one in a floor of a temple. And I was wondering, because it's odd that the 4 outside borders sort of look like dipole antennas, but then they're all connected in a folded dipole. Looks just like those lobes that stick out on the sides.
That's funny you say antennas, because in a temple, if that was on the floor of a temple, it makes one wonder if that's the controlling Mandela for that temple. Because temples have like high points, low points, grounding points.
Well, if you ever find yourself in one and you're standing near it, or you're in a building like a courthouse that has a symbol in the floor,
yep,
look above you also.
Yes.
Yeah. I've been in my legislative buildings, the exact replica of Solomon's Temple, and I was in the rotunda and we did some tests with a flute. Don't ever do that. It zapped the energy out of me. It took me an hour just to. I had to sit on the lawn for an hour just to have the energy to get on my bike. Never again. Never. Blew my mind.
Ooh, Chris makes a point. What if a person was standing on each one of them dipoles doing what? Did he say chanting? Or she?
Right, chanting the Om,
Energies
because that
manifesting.
is the cymatic
Right.
mandala of Om.
Yeah, then you resonate with that temple and that Mandela, and whatever purpose that resonation was for would be accomplished. So
Yeah,
it could go into the topic we can't talk about.
Yeah.
might be able to teleport you, or at least your consciousness, right?
Maybe.
Toning with the Om symbol built in.
Well, that's kind of funny because the sound that the generator I'm working on makes is Om, Om.
Really? That's fascinating.
Have you ever seen one of these? If I can get it spinning, since it's got to get it wound up.
Oh, get out. I haven't seen one of those in a while.
I'm building a generator out of this idea. But when you get this thing humming, it's like when the strings open up, they go whoom, whoom,
Yeah.
whoom. So I call it an impulse generator. My mother showed me this at 7 years old when we moved here and was waiting for our furniture to arrive. She didn't have the bow. I added the bow because it's a spring, which gives me the ability to keep it going. But when I was a kid, I had a dream that me and a black man were talking, and I was in some tribe where they were all bouncing around wearing penis sheaths and shit. And I was like, hey, I come to show you guys something. And they were laughing at me going, we already know. And they took the disc out of their lip and they put it together and they're like, we already know. We've been waiting for you.
Dang.
That's
Now
wild.
I
that's
thought
cool.
I had something, you know, but they were telling me nothing new under the sun.
But that vibration that comes off of that's like a resonant vibration, isn't it?
Yeah. The
Yeah.
electric string, which is one of your musical instruments.
And
The
probably
ball
the
string.
exact frequency or wavelength of the actual. Wow, that's cool.
I've had this since 7 years old, and I'm 60 this year. I was born the year of the dragon. This is my 5th round as a dragon. I'm a positive wood dragon, which associates it with the word. Not to say I'm special, it's just, yeah, anyway, I love you
Yeah,
guys.
there's legends of dragons that were good and
They make
wise.
changes. Dragons bring change, and we're in
Yeah.
a year of change, most definitely.
Oh, yes, we are.
So we're talking about the shape and the frequency.
Yeah.
So right here, the earth, water, the ether, the shape, the frequency. I had it wrong when I emailed you and I found out my answer. Just so you know.
You're bang on with this, though. It's the key part of like the dimensional quality of the geometry and like physics of matter and the material that you're going for.
Yeah, so check it out. Hold on, I got another one for you. And I always got to look at something when it has counter rotation and it has music symbols on it.
That's
like
meant to be interlaid, one over top of the other. One with a see-through piece of plastic like cellophane, and the other one dark. when you overlay them, you're going to see something else. I don't know why that just came to me, but maybe I'm wrong.
Portal, maybe?
No, I don't know about that, but it's going to show you something. These patterns look like they interweave, like they overlap. Almost like they're trying to show you something. I don't know. Maybe I'm wrong.
Well, I told you the Russell periodic table is in the counter rotation of the actual funnels. Okay. It's all right there.
I want to look at that closely.
So,
you know what I mean? Like,
can we zoom
I know
in?
I don't think you can zoom in enough to look at it, but maybe send me the link and I'll have a good look at it later. How about that?
Yeah, I don't think I can. It's just ironic that all this stuff is out there and they haven't put it together.
Right?
You know what I mean?
Because this stuff requires people that think outside the box. And academia puts everything in a nice, neat little box with a nice little trim.
Well, they keep building things in 2 dimensions.
Yeah. They keep building things from their ego. Shouldn't say that.
Wizard, I'm not sure if I have yet.
I'm actually gonna have to bail right away, guys. I gotta get up early, so just as we're beginning to flow, I gotta cut the flow off.
I've been going for 5 hours, so
yeah, I know. Nathan's ready for another 5.
No, I'm not. I'm dying here.
Ready to rumble.
Nathan's ready for dinner, so no worries. We could cut her off here and see you guys soon. And yeah, I gotta work tomorrow.
Definitely. I'm sorry I wasn't in for the whole show. I missed Shawn work and some other stuff, but I'll go back and watch it again. And I've committed to the 19th for my presentation.
Oh, did you hear that, Bernie?
Oh,
very nice. Yes, it did.
I'm committed. Or I'm going to be committed. No, 19th. So, yeah, we're going to get that done. And Victor, I want to do another, we have to do another show.
Yeah, definitely.
Yes, we all do.
Yeah, definitely. There's so much back and forth, so much synchronicity because it's a flow that we got to continue this.
Well, I think that we need to do one of those behind the scene things again, like we did a little while ago, and bring everybody in because it's you have to talk about the other subject in order to flow the whole thing, and then everything is going to go off.
Absolutely, because there's parts missing out of our conversation that connect to this that we can't. Yeah, you're not wrong. You're dead on there.
And it has everything to do with this scale, by the way.
Yes, it does.
Showing. That's why I'm telling you where it is. That's why I told you how the shell's grown. That's.
Oh yeah, I never thought of it like that. That's a good point.
There's a way everything works, and there's a way that everything interacts together. And like I don't know how better to say it. Put the pieces together. We're creating a transformer here. Okay, it's this piece goes here, this piece goes here. Manipulate it, put them together. I mean, we're playing Tetris with this stuff.
This is the formula.
Yeah,
big time.
That there's a second scale that goes to this. Okay, that it's about the subject we can't talk about.
Yeah.
Okay?
Yeah.
And they intertwine.
Yes, they do. I want that link later if that's possible, Nathan.
Okay. It's outrageous. It was all right in front of our faces, but they separated it so much that it was not able to be seen correctly. And part of why I was trying to make the video is I want it all to be seen correctly.
Absolutely. Oh man, my presentation, people are
Need to
gonna
see
get it.
that.
They're gonna understand now totally because of everything that's been talked about and gone through. Now I'm excited.
That's
All
what
right.
it's about.
I have to bail though. It was good discussing with you. What's this stuff? See, you're gonna keep going, man. I'm not gonna leave. I'm gonna get the stink eye.
More Walter Russell, but this is a rabbit hole for another day.
Yes.
So,
I love Walter Russell's work.
right?
It really coincides with some of the stuff that is being done right now.
It really does. All right.
All right. Thanks
Lots
again.
of it.
Thanks, Ben. Thank you very much, Victor. Thank you, Bernie. And Nathan, as always, it's been a pleasure. It's been awesome, you guys. You guys are
Of
great.
course. Pleasure's
are you.
mine, Gerald.
And we'll
All
see
right,
you
guys. We all taking off now?
I
Yes,
am.
sir.
Yeah.
All right, guys. Have a great day. Thank you guys for very much in the chat. Thank you for the great stream, guys.
Yeah. Thanks, Nathan, Bernie,
No
Vic.
problem. See you
Good
guys
night.
soon.
Have a good
I'm
night,
gonna go
everybody.
watch
Thanks, chat.
cryptos.